Okay, all right. I think you're ready to start a stream.
All
But
right.
I hear an echo in your from your side. I'm not sure this is from your side or my side, but I hear echo.
Let me mute myself in the streaming software and then see. Do you
Okay.
still hear the echo?
I think no, it's okay now.
Yeah, I hear, but there is still echo.
There is still echo. I'm not sure then where it's from because it's not from my side then I guess.
I
I
think
think as
it's
far
better
as
now.
I think as far as you are speaking like from your side, it's okay.
Okay,
Yes,
so
okay.
let me know if now it's okay.
It's okay. It's okay.
All right, so we're good to go?
I think you can stream, yes.
All right.
Okay, so far we have 55, 56 attendees. Still they are joining. So we are waiting a couple of more minutes. So in the meantime, while we are waiting for the people to join, I'm going to play you a very short music, just a couple of minutes to enjoy. We are expecting more than 100 participants in this event, so just want to make sure that if you can see me. So can you see me?
Yes.
Yes.
Okay.
I think, Mansur, your voice has some noise. I guess there is a problem in your voice.
Okay. Are you sure there is problem with my voice? Like, can you hear me loud and clear?
Yeah, we can hear you, but there is some interruption in between your words, and I don't know why.
First and then speak so we know where the problem is from. Can you please of us?
Okay. What now? Like, how's the voice quality right now?
It's better, I guess.
Okay. Just a second.
Maybe this might be the problem, like the speak. I mean, the mic of Sadia is open. I think this is the echo from.
Yeah, I think still we are hearing echo from Sadia. Sadia, I just want to ask you to mute your the current WebEx right now to see if we still hear echo.
I muted for like a couple of seconds. I'm gonna mute again and please speak and see if it's okay.
Okay, Intikab, can you speak to make sure that still we have echo or not?
Okay.
Yeah, it's fine right
It's
now.
better now?
So I think the echo is from Sadia.
Yeah, I think it's better now.
Okay, while Sadia, you are fixing that problem, and while we are waiting for the other attendees, I'm just gonna play a music for a couple of minutes, and we'll come back to you very soon. Okay?
All right, sounds good.
While sleep has taken you, where I'm out of sight, I'll make my getaway, time on my own. Search for a better way to find my way home to your smile. Wasting days and days this fight, always down and up, half the night, always still reminisce further down. We'll only sacrifice what time will allow us yourself. All alone, though you're right here. Now it's time to go from your sad state. Make my getaway, time on my own. Leaving's a better way to find my way home to your smile. Your smile.
Okay, everyone. I'm sorry if you hear some like couple of noise in the voice. So we are almost ready to start the event. So first of all, if everybody has access to the chat box, I believe you already have access to Q&A and chat box. Please feel free to ask your questions. My name is Mansour Nasl Charaghi. I'm chair of IEEE Young Professionals Affinity Group of the Montreal section. I warmly welcome every attendees and our respective speakers for this event. Hopefully, everybody is going to join and enjoy this amazing event, and you will get most of it. So I'm going to briefly introduce our co-hosts. This event is co-hosted by Young Professionals Affinity Group of Toronto, Ottawa, and Vancouver section. We have student branches that they are hosting the event: INRS University and Concordia University, Polytechnique Montreal, and ETS University. So these universities are from Montreal. We also have co-hosts from Ottawa, which is a Women in Engineering. It's a separate section of the separate affinity group of the Montreal of the Ottawa section. And we have Vancouver joint chapter, which is Circuit and Systems from Simon Fraser University. Dr. Trakovic, I'm sorry, I'm not ruining her name. She is the co-host of this event. So our speakers, we have Sadia. I would like ask you to please, you and Faye, please turn on your video while I'm introducing you. Thank you, Faye. Sadia, if you can hear me, please turn on your video as I'm introducing you and Faye.
Okay, so our participants will be able to see me, I think, on our Facebook live stream, but not maybe here.
Okay, no problem. It's okay. It's okay. It's okay. No problem. So yes. So just to make sure that okay, I introduced our co-hosts more appropriately before moving on to introduce our respective speakers. Moin, I just tried to make you co-host. I'm gonna try again. So maybe this time it will work. Just give me a second so can try again. So maybe I can do it like after introducing our speakers. Anyway, I just got your message right over here. Okay, our speakers. Sadia Khaf is from ETS University. She is PhD student in electrical engineering. Of course, she will introduce herself in more details if she wish to. And the second speaker is Faye Satari. Faye is from Polytechnique Montreal. She is master's student in computer engineering, and she will introduce herself as well in more detail if they wish to. So I'm just gonna make sure that they can present, they have the presentation access. Just give me a second. So first I'm giving access to Sadia to, I'm changing the role to presenter. So Sadia, I think you are able to present.
I
And
think so.
afterward, yes, I'm not sure I can if I make Faye, okay, just hand over. So it's gonna like a handover. So I'm gonna like return to you, and then we can move to Faye when she wants to like share a screen. Anyway, you are presenter role right now, and I am handovering the microphone to please introduce your events and the agenda and what will come and what we're expecting from this event. And thank you for accepting our invitation. Actually, these two speakers, these are like our active volunteers in our team. It's a great honor to have them like as the team member and as the lecturer at the same time. Thank you.
Thank you so much, Mansoor, for the wonderful introduction. I would like to welcome all the participants to this exciting event. We are so humbled and overwhelmed by such a large participation. Thank you so much, everyone, for joining us. In this event, we will start with my friend Faye. She will be giving you an introduction to Google Colab, which is a wonderful tool. This is like your coding in your browser. You don't need to install anything. You don't need to go through, installing the dependencies or anything. You can just go into a browser tab. All you need is a Google account and you can start coding into it. So Faye will be telling you how to do that. She will cover the basics of Google Colab. She will cover how you can use your file system into it. She will cover how you can start writing codes, different blocks in it. So you will get to know how you can start writing your codes using Python in your browser, like a Jupyter Notebook. And after that part is covered, I will take over and we will start writing our Q-Learning code. Faye will also introduce you to some gym environments that later I will be using in the second part of the workshop, in which we will give you an introduction to OpenAI gym environments. OpenAI is a library of open source environments for reinforcement learning. So we will have an introduction to what kind of environments are there, how we can use them, what kind of functions are there. And after that, we will move on to writing your first Q-Learning code together with us in your browser. I hope you guys got the template file, code file in a GitHub repository. So we will be, for the second part of this workshop, we will be using that file and you will be writing the code with us in your browser. For both the first and second part, you will open a browser tab and you will write your codes with us so that when you leave this workshop, you will have already completed your first reinforcement learning code in your browser within a couple of hours. So I hope you will learn a lot from this workshop. Without further ado, I will hand over to my friend Faye and she will start giving an introduction to Google Colab to you. Over to you, Faye.
Thank you, Sadia, and thank you, Mansoor. Hello, everyone. Thank you to joining us. I'd like to send a very welcome to all of you on behalf of our entire team. I hope this workshop would be an interactive workshop and helpful for all of you. Hopefully, it transfer your knowledge to more professional stage. Before we go further, I'd like to take this opportunity to a quick introduction of myself. My name is Faye, and as Mansoor mentioned, I'm a master's student in Polytechnic Montreal University. I'm a computer engineering student, and my research area would be smart cities, IoT, 5G, and security. Now I'd like to share my browser with you. Okay, let me share. I hope you now see my screen, please.
Yeah, we see you. It's okay. Go ahead.
Okay, thank you. As Mansoor and Sadia mentioned in the first section, we are going to talk about Colab and what's the Colab and how we can start coding in this nice platform. I'm prepare these documents and these subjects for you. I hope we have enough time to talk about all of them. And I will appreciate if you have any question, put it in the chat and we will answer them if we have enough time again. Okay, let's go and start our first part. I'd like to start with a very quick introduction of Colab. What is the Colab? Colab or Colaboratory is an amazing tool provided with Google to use their fantastic built-in library, broadly speaking, to online coding in Python. There are a lot of nice features and facilities in this cloud-based infrastructure. Actually, it's a cloud services that gives you ability to write and execute your code online on your browser with no need to any installation and setting up on your local machine. And also it brings you a free GPU and TPU, which is a great feature in this platform. I will talk about this part. And there are other stuff like you can easily share your file and other things that we will talk in the next parts. Before I get started and create the first notebook, I'd like to ask my colleagues make a poll, and I'd like to answer you a question. I'm just curious to know how many of you now have experience working with Colab, and how many of you are experienced working with Python. It's very great if you participate in our pool and answer these two questions.
Okay, perfect. I think Intikab is just polling stuff. So just a second, so he can like Intikab, I think you have access to polling questions. So please pull up if you have them already, like on hands.
Okay, just I can't see the result. Mansoor, if you help me to find the result, I will appreciate.
No, it's not like it's not initiated yet. It's under preparation right now. So just
okay.
I
can go further and when
move on. Please move on.
Okay, sure. How we can create the first notebook? I assume that you don't know, and I just want to share with you. You just need to go in your Google and just search Google Colab, The first link that you can see, colab.research.google.com, it redirects you to the main interface of Google Colab, which you have access to this link, new notebook. If you click on it, it brings, you can start creating your code in your notebook. Another way that is interesting and I like to show you is that you can go easily to your drive here and click on new. Here you have different format of files that you can create. One of them is Google Colab. Just a tricky point here is that if you don't see Google Colab here, don't worry, just you need to click on connect more apps, and here you can search for Colab like this. Colab. And as you can see, I'm already installed the Collaboratory on my browser, but if this is the first time you are going to use, you just need to install it on your browser, and then you have access to this type of files here, and you can click on it and create again your notebook file. I want to suggest you start creating your notebook with me and start coding on it and get ready for the next part that you are going to work with Sadia. It seems that Intikhab sent the pool. I will appreciate if you answer these questions. It helps me to manage the content more efficiently for you. Mansoor, I waiting for the results.
Say we still have a couple of minutes left for the participants to answer. So let's see what everybody thinks and how they answer. I think it will be available in a couple of minutes.
Okay, so I'm going to further. Let's start talking about different facilities and settings that we have in Colab. I'd like to start with how we can change the name of your file. You can put your name of your file here or change it. For example, I like to change the name of my file. So simple, and just you need to save it, just this. Another things that we have a setting here. For example, you can change the theme of your browser to dark mode if you like, or let's back to the light mode. Or there are some stuff here to setting up the font size and other stuff in your browser for beautifulness and easiest way to work with. There is a funny setting here. I like to show it. I set it in menu power and save it. Then I start typing, and as you can see, it's just funny setting that you can enjoy it and don't get bored of this coding platform. Let's back to the normal state. Okay. As I mentioned, you can create table of content for your documentation and your code here. Just you need to add a section, something like this, and then you can put a name here, anything, test section, for example. And as you can see, it will add it to your table of content. You can move on and access to the section. You can search and replace like as other browser, other document platforms. And also, okay, I will back to code snippets in the next part. We have a place for your files and working, putting any file that you like to work. Let's try to, for example, I like the picture. Okay, it brings you a alert that this place is a temporary for your file, which means if you close your browser, if your session will be ended, then you will lose your file and your file will gone. So we need to have a permanent place for your file. We will talk about it. But before that, I like to mention about GPU and TPU, as I mentioned, which these two features are the important and a nice feature in Google Colab. In my point of view, the most important feature that distinguished Colab from other cloud-based services is that you have free access to GPU and TPU. How you can use them? You just need to go to edit and then to go to notebook setting. Here you can change the hardware accelerator to GPU or TPU, as you can see. But what's the GPU and what's the TPU? Before I talk about these two, I like to show you an example. I don't want to talk about the whole code that we have here. I just, okay, before I probably give a error message because I didn't change the GPU and CPU as my hardware accelerator. This code provides two random array of images and start manipulating these images in two different modes, CPU mode and GPU mode. And it's going to compare the result of these two different modes for considering the time of processing. As you can see here, with CPU, it takes around 3 seconds, but with GPU, it takes around 0.04 seconds, which means GPU is faster than CPU around 76 times, which is very great when you are going to work with images, videos, and you have a complicated algorithm and you need to have a better and faster solution for your algorithm. Okay, I can see the result of the pool now. So it seems that you guys have already experience working with Python. Nice. So it's make it easy, this presentation, and I'm glad that see some of you have experience with Colab. It's so nice. I hope you don't get bored of my presentation. And for those that don't have any experience with Colab and Python, don't worry, because if you know any other language, the syntax of Python is very simple and you don't have a big trouble to deal with this language. You can see in next minute. Okay, back to my presentation.
Faye, sorry for interrupt. I wonder if you can like a bit increase the font size, because I see the same situation here. Like, can you please increase the font size of the browser?
Sure, I will do it. Thank you for your notice. Is it better now?
Yeah, it's much better, much better.
Okay, thank you for give this hint to me. Okay, GPU or graphic processing unit, and TPU, which stands for tensor processing unit, are two features that gives you different hardware accelerator for processing your algorithms and codes. The main difference between GPU and CPU is that CPU is mainly designed to handle a wide range of tasks in considering the CPU time, and it's have some limited to work with concurrency tasks. Instead, GPU is designed to quickly render huge images and videos concurrently. Also, about the TPU, I'd like to mention that TPU is an application-specific integration circuit to accelerate the AI calculation and algorithms, which provided with Google for the first time. They developed it especially for neural network machine learning, for TensorFlow software, and they started, Google started using of TPU in 2015, then they made it public in 2018, and now here we go, we have free access to TPU in your Colab, in your browser, with no need to installation. If you are going to use TensorFlow project, it's a very nice feature. I really suggest you try it. I want to talk about different kind of cells that we have. We have two types of cell, code cell and text cell. As you can see here, what we have until now, all of these created by a text cell. So it means that you can put images, text, headings, bullet lists, and other stuff. As you can see in a text cell, I'd like to show you the edit mode of a text cell. For example, you can simply Google, add a link like this. Just you need to add the URL, google.com. And if you click on it, now you have your link, or you can add the image. And one nice feature in Google Colab is that you can write any formula, any equation, like as what you can do with LaTeX here. Just you need to put your formula between two dollar signs. For example, I like to say something like this. You can see the result real time in the right side. Okay. And if you double click on it, you go to view mode. If again double click on it, you go to edit mode. It's so simple. I don't wanna put a lot of time in this part. Let's go to the next part. As I mentioned, you have a very easy way to share your notebook with other people, like as other services in Google. You just need to click on share and then choose any person that you like with his or her email. Then you can choose three kind of permission as a viewer or commenter or editor, and just send the invitation for share this notebook with this. Or you can use the specific link. Again, you have for example, you can choose these two types of creating the link, and you can put the permission for your link again, which is a nice feature. And for example, you can create a link with viewer mode and put it in your website, weblog, any place that you like. It's so simple to working with your colleague or your teammate in one notebook. If you guys are used to working on GitHub, you can save your Colab notebook, your notebook version in GitHub like this. Just you need to click on GitHub and then log into your GitHub. Okay. Then you should choose a repository or a branch. And a branch, I like to create a new repository. Just let me name it, for example, IEEE workshop. And I add the README file. It creates a main branch automatically. Then if I back to my Colab, let's cancel it. Again, go to save a copy in GitHub. I can choose, okay, I don't know why it's don't come here. Maybe I made a mistake. Okay, I choose another branch, okay, like this, and I save it here. It gives you your notebook, copy a notebook in your GitHub, and then you have access to open it in your Colab directly from your GitHub, which is a nice feature. Let's back here. Also, you can download two types of version, Python version and IPython notebook version, which you can brings your file to any idea that you like. Another thing that I like to show you is that, as I mentioned, you can work with your file as an input or as a saving your result with this content place, but it's a temporary place. So if you need a permanent place for working with your file, there is an option here that you can mount your Google Drive in your Colab. Just click on this part. As you can see, it adds a very small piece of code here. If you run this code, it brings you a link. And if you click on this link, so you must choose your account and then allow the permissions that needs. Here you will see a link. Just you need to copy this link and back here, paste it here and press enter. What will happen is that you will see a drive in the left side. As you can see, if you go to this path, you can see all folders and files that you have in your Google Drive. You can create a specific folder for working with your notebook and put your file there, or retrieve any file that you like from your Google Drive. I will back to this part in the next parts. And the final thing that I like mention is that there is a revision history in your Colab notebook, which means you have option to compare previous version with current version and find what's happened in different version in your Colab for history of changes in your notebook. Let's say and talk about the code cell. As I mentioned, we have two types of cell, text cell and code cell. This is a code cell. I want to add another code cell here and start with very classic hello world. Okay. For running your code, you just need to click on this button and the result will be appeared here. You can clean up the result. Again, you can run it. There are other options with keyboard that you can run your cell code. I mentioned here, you can see. Any cell code have and even any text code have some settings and tools here. For example, you can move up or move down your cell with these two buttons, access to direct link for any cell that you like. The same setting that you see in the top, you have beside of any code cell. And you can delete it, copy, cut, and other stuff that you can see here. Another feature, nice feature that I like to mention is that you can put some note beside of any cell that you like. This is a test. And if you put this comment, and if you work with, for example, anyone else in one notebook, you can communicate in one cell with your colleague or your teammate. For example, this is a test again. Finally, if the problem is solved, you can resolve your comment. What's happened is that these comments and the history will be go to this comment. You can see the history of your comments and replies and other stuff here. You can reopen it, which it brings it back, or again, you can resolve it. It's very nice feature if you working with other people in one notebook to communicate and make some comment for other people in a notebook, or even put reminder for yourself. It's very nice feature. As I mentioned, you don't need install any packages or libraries like as other IDE when you are working with Colab, which means you already access to all the famous libraries such as Pandas, NumPys, I don't know, TensorFlow. All of these libraries are available in Colab built-in, and you don't need install anything. Just import library that you like. Sorry, I want to import, for example, NumPy. Here we go. We don't need to install, and we can use this library without any installation. For example, I like to see the version of my NumPy version with this command. You can see that NumPy is already built-in, installed in your Colab, and you can use it with no need to installation. Other libraries, as I mentioned, like as Panda, SciPy, or TensorFlow are the same, and you can use them. I just want to mention that we have different types of packages and libraries. For example, we have NumPy and SciPy and Panda for science programming. And NumPy more specifically is useful for working with multidimensional arrays and metrics. Or we have some packages for specifically for machine learning programming, like as scikit-learn, TensorFlow, PyTorch, and other libraries. And we have also Pygame or some libraries for reinforcement learning and gaming programming, which we are going to work with in the next part, specifically with Sadia. So most of these libraries exist in your Colab notebook. If you want to know which libraries already exist and you have access, you just need to use this very simple command, just this. With this command, you can see the all library that you have access here with the version. For example, you can see we have the TensorFlow, and the version is 2.4.1. I like to bring you another nice command. For example, I like to import pandas, but I don't have any idea about pandas. Don't worry, you just need to give a directory from pandas with this very simple command, and if you run this, okay, now you have access to all methods and functions inside the pandas. You see, it's so easy working with Python with this simple commands. Now, if you want to know about any of this function and have more information, you can go with this. For example, I don't know, for example, I want to know about eval. I don't know what is this. You just need to add a question mark at the end of your function, and then if you run your code, okay, here you will see the signature, the input parameters, output or return value, and even it brings you some example, coding example, which is nice, and you can easily find how work with functions and how they work for you. There is another way you can use this command help. It's the same with the previous command. Let me go a little. Okay, now it's better. It's the same with the previous command, and you have the same information here, and you can use them. I think you already know that if you hover your mouse in each function or package, you will have a very quick access to some useful detail like this. And it's another way to access information, if you like, in Colab. Okay, let's go to the next part. I think we don't have time to more talking about this part. Okay. Some libraries and packages does not exist in Colab. You need to install them. For install, you just need to use this very simple command, pip install package name or apt-get install package name. Both of them are the same. The difference between them is that pip is use of repository of Python for installing the package. Apt-get use of repository of Ubuntu for installing the package, and go there and download the package. I bring here a link for you. You can go there and find more information about apt-get and other options and parameters that you can use with apt-get. I recommend you go and find the same thing for pip, because we have the same thing for pip. For example, if I want to install this specific package in my Python, I just use the exclamation mark pip install and matplotlib, the name of package. If I run this, because I installed it, it says already installed, but if it doesn't exist, it's a start to installation. Or for example, here I have another installation with apt-get, which is a start to installation. For example, I use the -y, which means any confirmation during the installation will automatically say it by yes and confirm. You don't need to install. After installing a package, if you want to know and ensure that your package is installed very well and perfect, you just need to use this simple command. Pip show the name of your package, brings you the name of package, the version, the path that it's already installed, and other information, which means you have access to this package right now in your browser. I talk about the show. I don't want to run these codes, but it's good that you know we can upgrade our package with this simple command: pip install --upgrade the name of package, and you can change the version of a package in your browser with this command: pip install the name of your package and the number of version that you like. You can change the version. I want to go to the next part and start plotting some charts with together. And I've seen that you answered to our poll about which favorite tools that you used before for providing charts. I'm not sure about the result, but I want to share with you Python. They have very powerful packages for plotting. When you using with high volume data, and when you want to bring some statistic reports, it's a necessary thing that you put some chart and diagram in your report if you want to be professional. So I like to share with you how you can plot some chart and diagram based on your data in Colab with Python. We have different packages such as Booke or Seaborn or other packages for creating diagram, but I like to go with one of the famous and powerful one, which is Matplotlib. Let's go and start creating some sample data for our plotting. I like to use NumPy. I just go with, again, import NumPy. And then I like to define some array. The first one, 6 in range 1 to 12. Let me print the result to show you what is doing. Okay, I create an array with integer between 1 to 11, not including the 11. This is a way that you can create an array in Python. Or I like to use another ways. For example, this time I go with NumPy and create random numbers with random, and specifically I want to use randint to create random integers. So I want to start with 1, and the latest number that I like to see, for example, it's 8, and the size of my array that I like, it's 10, something like this. And if this time I print Y, you can see the difference between two commands. Okay, as you can see, the first one create an array with 10 items, which they are 1, 2, 3 or ordinary numbers. But this command provide an array with 10 items, but it's a random integer between 1 and 8, as you can see here. Let me just very quickly create two other. This one would be x2, and this one would be y2. For example, 6, and for example, 9. These are just sample. Okay, I create 4 array with 10 items for each array. Now I'm going to plot some charts based on these data that I have. For plotting chart, first of all, you need to import Matplotlib, and specifically, I like to use PyPlot. So as I mentioned, for plotting, you just need to use a very simple command, which is plot, and put your data. I like to use x1 and y1 for my data, and after that you should show your plot, which is the simple command, which is show. Let's see the result. Here we go. We just create the first plot together, very simple. I like to create another chart, but at the same, I mean, I like to create another line based on, for example, x1, y2 in the same chart. I just need to another plot, and then you can see here the result. You can easily plot any data that you have in one chart. It's so simple. You can add, for example, title for your chart to make it more professional with this command. For example, first chart, I name it first chart. Here we go, we have it here. Or you can label the X and Y axis by this very simple command, plt.xlabel, and name it X value. Sorry, okay. And the same thing we have for Y label. This time I like to put a formula. As I mentioned, you can write formula here. I like to say this is X equal Y. See the result. You have a formula here. You have a label for your X's. Another nice thing that you can do is that you can use the grid to make your diagram like a mesh and grid. Also, I like to use plt.x ticks and give it x1. What is going to do is that it brings this exact measurement based on your x value in your x-axis. You can do the same thing for y-axis, but I don't want to do that. Another thing that we need for our chart is legend. I like to label this one first line or line 1, and this one line 2, line 2. And then if you add this command, legend, what's happening here is that, oh, maybe I made a mistake here. Okay, it's a nice thing. If you have any problem in your code, you can see the error like this in the your output part. I made a mistake in my syntax, and okay, now you have the legend here. Another thing that you can do with your plot is that you can use of this figure function to resize your chart. It has a parameter which is fixed size, and it takes height and width, for example 6 and 8, something like this. Let's see. Okay, maybe I change it. It's better to change it, for example 8 and 6. Now you can see you have a bigger chart. Also, you can give some style, for example line width to your lines, or you can give a style, line style. style to your oh, I made a mistake. Line style to your charts. You can see here, or you can add marker for your chart, for your line marker. I like to go with O. Can you see it's add some marker for your points, and you even can change the size of marker size, and make it, for example, 10. You can see the how you can set some beautiful style, or even you can marker face color. You can change the color of marker. I like to go with, sorry, light blue to make it more beauty. Okay, I made a mistake here. Let's say marker face. Okay, face. Oh, sorry. Color. Okay. So you can do very simple things to create a very beautiful line. I like to add the same thing for the next. Just let's remove this. And even you can set the color for your line. I like to add red and change the color for the second line. Okay, we have a very beautiful chart with very simple commands. You have the same style you can add for title and your labels. Another thing that I like to mention is that you can save your chart as a PNG file with this function. For example, name it fig1, and let's save it. What will happen is that if you go to this place, okay, you have it here, and you can download it in your computer and use it any place that you like. We have other types of charts. For example, we have bar charts. Let's look at the bar chart with X1 and Y1 and plt.show. Okay, here we go. We can do the same thing and put another X2, Y2 here. You can see we can add all of these things that we put in the previous plot here, and now you have another beautiful plot like this. If you can see you don't have a legend here, you should label it. Let's label it bar 1 and label bar 2. Now we have this. Or another type that maybe it's interesting to talk, a scatter. It's another type for preparing some beautiful charts. It's X1, Y1. Now you have a diagram like this. Okay, there are a lot of beautiful charts and diagrams and styling them. We don't have time to go with them. I like to show you some samples in code snippets. We have code snippet here. You can search, for example, visualization. Okay. If you see here, there are beautiful and very professional samples. You can use them and give some idea from them. I like to test one of them. I don't know what is this. I just insert the code inside of my notebook. And if I run this code, what will happen is that Here we go. We have a very beautiful chart. It's interactive chart with changing your moist. It moves, and you have options to save and other options. You can find other nice samples here and use them to take some idea, to find some idea and use them in your work. Let's move on, and I prepare some sample here. Let's say we are going to calculate z equal x2 plus y2. I prepare some array with 40 items, two array A and B, and then use those two array with mesh grid to create a two-dimensional array like this. So now I have x and y, two different array, two-dimensional array. And then use them to calculate the z based on my formula like this. Okay, let's print the z. Maybe it's not bad to print the z. Here we go. Now I'm trying to plot the z based on x and y. As you can see, it would be a triplet. I write the code here because we don't have time. I just run the code. And this is the result, which I use, again, the matplotlib. I put the size for my chart, and then set the 2-dimension as my axis, use the plot surface nice function, and set the x, y, and z as my parameter. And this is just the style of my color map. And also I use the contour to create a contour for my z dimension. You can change it, and I set the offset 0 to create my contour in the 0 point of my options. And again, it's a I change it to see you what's happened. I don't know what are these. I just check another one, for example, this. Okay, it's just a color map, different color map that we have in Python, and you can use them for your chart. And another thing is that you can create a color bar like this with a very simple command. Okay, all things about the chart. I think we need to go to next part, pickling. If you want to work with files, especially if you have dictionaries and some objects that you like to save it in a file, it's a good option that you use of pickling. It's so simple working with pickling. Let's do it together. First, I like to create an object, for example, my object, obj, and my object would be include x and y, and then z. Okay, I create just an object based on the arrays that I have. Now I like to import pickle. Okay, it's a nice way to working with file. Then you need to create a file. Let's name it file out. And then with command open, you can open a file with any name. Let's go with file test, something like this, .pickle. And sorry, pickle. And then, as I said, I want to write in this file, so you need to pass the parameter W for writing and B for byte stream, because I want to write a byte stream in my file. Then the things that you should to do is that use of pickle. and use of this function dump. Then put your object, which is my object, and your file, which is, for example, file out. And finally, you should to close your file. Okay, let's run this code. Okay, what's happened is that now you have your file here. If you click on it, you can see the result here. It doesn't make sense because it's a binary file, but we can retrieve it in our code again by very simple code. Let's say file in this time. I name it file in, and then again, I like to open my file. Which file? The same file that I created, this file. And this time I want to read my file. So I put the write as my input and again binary type. And then you should to load your file with this simple command, pickle, okay, dot load, and put your file as a parameter there. I like to save it in a variable. Let's name it temp variable. And for showing to the result, I like to print it. Okay. Now we start reading our file, put it in filein, load it in a temp variable, and use it for print. You can use it in other codes, part of code. It's so simple working with pickle files. As I mentioned, this place is temporary. So if we want to work with our drive, what should we do? Let's go with together and see what we can do to saving a pickle file in your Google Drive. Let's try with the same code that we create this file, but this time I go to Drive, my Drive. Let's say I'm going to save my file in this folder. Just I need to copy the path and paste it here and add a one backslash. Okay. Now if I'm running this code, what's happened is that if you go to your drive and open this path, you will see that now you have what is the name? File test here. You have the file test. Let's change the name. Let's name it in Drive. And again, run it. And I want to refresh it. Now you have file test Drive here. It's so simple. You just need to click on it and copy the path. Again, you are able to read file from your Google Drive with the same structure like this. I like to copy this. Let me go with this file and change the name, for example, 1.1.1.1. Okay, here we go. Again, we read the file from our Google Drive. It's so simple. Also, you have option to save your file with a very simple code, which is I like to share something with you from Google.colab. You just need to Colab. You just need to import files. Okay. Then you can use the files and download and just put any address, any path that you have. Let's go with the file that we have in our Google Drive. If I run this file, what's happened? Okay. files. That's me. That, yeah, I made a mistake, I guess. Okay. It brings you this feature that you can save your file in your device. You can do the same thing with the file that you have in your content. For example, if you like, you can save it this file, not different. Again, you are able to save your file from this place. You just need to give this permission to your browser and then save your file here. Okay, for the next part, I like to talk about some libraries that you need to install for working OpenAI Gym toolkit. We have some prerequisition packages for working with Gym toolkit. One of them is X libraries, which are actually a server that can run on your machine with no display hardware. So I want to install this package in my machine. I guess you will do the same thing with Sadia. Then you should to install a PyVirtual display, which is a wrapper to connect your browser to X server, and then finally you need to install Gym toolkit in your browser. I don't want to talk about these codes because you will practice them with Sadia. I just want to show you the result. It's just a preparation for the next part. As you can see here, you will coding with Sadia and providing something nice. It is a actually a Cartpool environment, and it's an agent-based coding which choose an agent from a random agent from a possible existing agent and provide this interactive environment. There are a lot of other environments. I just bring just one other example. It needs a very specific dependencies in Gym package. I install this, and then if we run this code, we will see some result like this. Again, it's another agent-based environment, which is mostly for physics problems. And there are a lot of beautiful samples in Gym toolkit. You can go and find them and enjoy them. I don't know if we have time. I like to show very quickly these two features. You can create forms in your Colab. Just you need to add a code cell and then go to insert and add a form field. You have different types of form field, and for each of them you have different types. I add, for example, a string and drop down, and you can see the result here. If someone choose some of them, then you have access to the result in your rest of your code, something like this. It's very nice. You can create a very interactive form in your coding here with Colab. And another nice feature is that you have a lot of facilities working with tables. Just you need to import the data table. Don't worry about this, it's just a sample set I just use for showing data to you. As you can see, you can create a beautiful table with sorting ability and filtering and other beautiful capabilities that you see. Thank you for your attention. Sorry, it takes a little more than 1 hour. I think you are need to some rest. I want to say again thank you for your attention and invite you to take a break and then back to me and Sadia and join to Sadia for the rest of this presentation. Mansoor, thank you.
Thank you, Faye. It was a great presentation. So is there any question that we can answer right now? Okay, let me check if there is any question.
Yeah, sure. I'm available for any question. If I can, I will.
Okay, just a second to see if we have a...
I think we have a question about Xtext for Faye. Someone asked, what's the purpose of using Xtext in the plot?
Excuse me.
Yeah, it's about the X-ticks, like a ticks of the X-axis.
Okay. Yeah. As I mentioned, okay, let's show again back here. Okay. Without Xticks, if you run your diagram, the steps that you can see here, it's by default with 2 steps size. But in my X, if we back to our X, it was with 1 step size. If I have to bring all the data for my X here, so you need to use our Xticks and set the value that you like, or even you can set another value. For example, your X has 1 million data, but you don't want see all of this as your measurement in your X-axis. You just can bring a value for your Xticks to show with what measure you like to create differentiation in your X-axis. I hope I answered your question.
Yes, thank you, Faye. I see one last question is about how could we do all this? I'm not sure I could understand this question, but let me read it for you. How could we do all this with just Python and not Google? I'm not sure what does it mean, but if it's
Actually,
like understandable for you.
Yeah. Let me, as my understanding, these codes that I write here, all of these are based on Python. So no difference about the IDE. You can do it in any IDE that you like. For example, Jupyter Notebook or even VS Code, any platform that you like. These are the Python code, no different. But the only thing that we have here is the GPU and TPU that, as I mentioned, it's very nice. And also we have some feature like as you can add the interactive forms, interactive text documents beside of your code and prepare a very nice code beside of your document, share it with your colleagues. These are the features that we use Colab in your browser, and you don't need to any installation for packages and add any other things in your local machine. So we choose Colab as our IDE, just this, no different for these commands. You can run it in other IDEs as well. I hope
Okay,
I
perfect.
answered your question.
I think we can take a very quick break. Sadia, would you like to take a quick break?
Yeah, I think our attendees have a lot to process right now. So we can take like a 10 minutes break and then we can come back.
Okay, yeah, please grab a coffee, take your time, and we'll come back in 10 minutes.
Yes,
Mansoor,
everybody's definitely gonna need coffee.
Sure. I just want to mention that I will share this file in my in our website, and if anyone interested can back to our website and find the whole codes that we write here and access to that. Thank you.
Okay, we'll come back. Thank you, Faye.
Thank you.
Okay, hopefully everybody has enough energy to proceed. Sadia, can you hear me?
Yes, I can hear you, Mansoor.
So you want to move on?
Yes, I got my coffee. Let's move on, I think. Let me just make sure some settings are all right. Okay, can you see my screen?
Not yet.
Not yet. Okay, let me fix that. I think I need sharing permissions from you. I need to be the presenter.
Okay, yeah, you have to hand over the presentation rule. Just a second. Okay, should be able to do it right now.
All right, let me try. Are you seeing my screen now?
Yeah,
All right, that sounds good. Let me just make sure I'm able to see the participants and if they have any questions as well, and we'll get started.
I think all you need is to just open the chat box or Q&A.
That's exactly what I'm looking for, actually. Because when I started sharing my screen, I sort of lost all the other
There
options.
should be a bar on top of your screen, like in the very top
right.
bar.
Okay. So if I click chat,
And
I
if you
should be
roll
able
down,
to
if
see.
you roll down your mouse screen, like you will see that.
Okay, perfect. All right, so now I see the chat participants. All right, so I think we are ready to move on to the second part of the workshop. I will start with a little introduction about myself. My name is Sadia Khaf. I'm a PhD student at ETS Montreal. I started my PhD about a year ago. Before that, I was a lecturer at Ghulam Ishaq Khan Institute of Engineering Sciences and Technology. I taught there for a year at the Department of Electrical Engineering as a lecturer. I was teaching third year and fourth year electrical engineering students. My teaching was mainly related to communication systems and digital control systems. I developed my interest in machine learning during my master's and also during my teaching and my research work at the Faculty of Electrical Engineering. So I decided to pursue my PhD in machine learning. Currently, my research is focused on using reinforcement learning for wireless communications and cognitive radio networks. So I'm basically trying to improve connectivity and provide better internet using reinforcement learning. I taught myself reinforcement learning, as I mentioned in my sort of introductory video on my YouTube channel about this workshop, that the best way to learn reinforcement learning, or the best way to get your hands dirty or start writing your code, is not really to take a course in reinforcement learning. That's the long way. That's the way if you want to do a PhD in machine learning, then yes, that's the right way. You take one course, you take another course, then you take another course, which is what I did, and that's how I taught myself reinforcement learning, and I started writing my basic code. But if you want to get started right away, if you want to dive in from day one, you want to write your code, which has been my approach with most of the codes that I've written in my life. I didn't know Python until a year ago. So the way I started learning Python was by giving myself a problem, which I have already done in some other language, maybe like MATLAB. MATLAB has been my favorite language so far. And then diving right away into writing the code in Python. Whatever I need to do, I just Google it. What this does is it develops your habits towards learning. It teaches you what's the best way to learn something, because the process is always the same. Whenever you're working on a new problem, the problem might be different. I might be learning Python right now. I might need to learn some other software tomorrow. But this process is easy to remember, especially if you have a bad memory like me. This process becomes part of your muscle memory, and you sort of know that, okay, I will start writing the code right away. And whenever I run into a problem, whenever I need to do something, I will just Google it. It becomes part of your habit. So that's what you should be doing if you want to learn something quick. If you want to learn any programming language quick, if you want to learn Q-learning, deep learning, any kind of new thing that you're trying to get into, get your hands dirty, get yourself into doing it right away. Because in the beginning, yes, you will have a lot of questions. You won't know what reinforcement learning is or how to do something, or you won't even maybe know how to plot a line or how to generate a sequence of random numbers, which you have been doing maybe a lot in another language. So you will just Google it. So that's what we're going to do today. In this workshop, we're going to start by diving into it right away. I hope you all have the file that I shared with you. If you don't have it, please let me know. This is a GitHub repository. Also, let me know if you have any previous experience with reinforcement learning. I'm not sure if you've ever written any Q-learning code before, or if you conceptually know what's the difference between supervised, unsupervised, and reinforcement learning. So we have created this poll for you. This workshop is going to be very interactive, so get your copies. I have mine. And we're gonna take our copies, we're gonna write our codes together, and we're gonna have some question answers while we're doing it. So I need your answers to this poll right now. Can you tell how to open the file in Colab? Well, you will have a link which will tell you how to open this file in Colab. Can you all just go to this repository? Do you all have access to this repository? If you don't have it, I'm gonna put it in the chat right away anyway, so that everyone can open it with me, and then we can take it from there. So this is the file. Don't try to run it because it's incomplete. It will run into some errors. Just clone this repository or copy this repository somewhere. And the way you can do that is by going there. You can go to code, and if you've done this sort of thing before, you can just clone it locally, or you can open it in Colab as well. So I would recommend opening it right away in Colab. To open it in Colab, this is just the README. You won't find it here. You will go to the first file, which is called IEEE hands-on RL. If you go to that file, you will find a link which gives you open in Colab option. So I would say head over there, click that link, open it, maybe make a copy in your Google Drive so that you can work in one file and you have another file for another time if you want to practice again. So you have the original file intact, or you can always come back to GitHub and you can get that file again. But I think we might be updating that file together. So before we start writing our codes, please let me know in this poll, do you have any previous experience with reinforcement learning? Any sort of experience? Do you know what it is? Have you written a reinforcement learning code before? Do you have even a little experience with it? So based on that, I will keep the pace of the workshop like that. If you all know about reinforcement learning, if you all have written a little bit, we'll go a bit faster. But if it's the first time you're trying to learn reinforcement learning, we'll go a little bit slow, and I will answer your questions along the way as we go. So please head over to the poll. I would encourage all of you to participate in it. Please answer this question so that this workshop becomes more and more specific to your needs, because we're all here to learn, right? So in the meantime, I'm gonna open this in Colab. Yes, this is the exact file that I have in my other tab, so I will go back and show you again. This is the GitHub repository. Please let me know if the font size and everything is okay. Okay, no experience, I want to learn. Very good, I'm very glad to hear that. That's amazing. Know some concepts, but didn't code by myself. I'm expecting that would be the majority of people who have sort of heard about reinforcement learning, that it's the next cool thing in machine learning tools, but haven't coded yet. That was me 1 year ago. I heard a lot about reinforcement learning. I even took a theoretical course in reinforcement learning, which teaches you all the math behind it, which tells you what are Markov decision processes, tells you why reinforcement learning works in the first place. So in the theoretical courses, you learn about convergence, you know why it works, you know what are the Bellman equations, how do the Bellman updates work. So if you're into that sort of thing, I would recommend taking some theoretical reinforcement learning course if you want to know the math behind it. But even after taking the whole course, I had no idea how to code it. I knew what policy iteration is, what value iteration is, but I needed to start coding it to actually know. Okay, we have the poll results now, and I think most people fall into the category of no. So all right, so we'll go a little bit slower, and if we cannot finish everything in this workshop, we can always come back for another. We can always arrange another one. So let me know always throughout this workshop if I'm going faster, because I want you to actually code everything with me. So if it becomes too fast, you can always slow me down. You can always let me know. I'll keep an eye on the chat. Can you please also recommend a course for maths behind reinforcement learning? Yes, any theoretical course on reinforcement learning would do. Just search MDPs, Markov decision processes, Bellman equations. It will take you, for example, you can take any course in, I would say start with stochastic processes. That might be necessary for some aspects of reinforcement learning. Then you can take any course in decision theory. So if you go to that, if you learn about Markov decision processes, you will start having a theoretical background of reinforcement learning. So have you all opened this file into your Google Colabs and made a copy of it? Once you've done that, please let me know in the chat and we will start implementing the code. This file, this is the file that you should be seeing. Okay, yes, you opened the file. All right, very good. Once you've opened the files, please make a copy for your own self so that you have it for later. And let's work on a separate copy so that, you know, if you need to go back to something, you can always go back to it. The first block is setting up the environment with everything we need. So we are basically just installing OpenAI Gym. We are installing a private display. There was a question in the previous section about installing the private display. So this step is only for Google Colab. You don't need to do it if you're working on your local machine. For example, if you're working in Visual Studio Code or if you're working in your local Jupyter Notebook, then you already have your computer screen, which is capable of opening separate windows. For example, if your graph is a moving object, then your computer can open a separate window to render that OpenAI Gym environment, and it can show you a video of the environment. But when you're working in Google Colab, we don't have that kind of separate screen which can pop out automatically and show us that video of sequence of events that are happening in the environment. So that's why we install something called a private virtual display. And these are the relevant libraries for that. Font, okay, I will make it bigger. Please let me know if you can see it properly now. If it's still small, let me know, and I will actually make it bigger for the Facebook audience as well here. I hope it's bigger without cutting. Okay, perfect, perfect. So this is something you don't have to copy. You already have it in your file that you received. So just run the first cell. Once you run it, it should install the libraries needed for opening a secondary display. Someone said you cannot hear. Is it just a one-person problem, or is everyone having trouble hearing?
I think I can advise the people, please, if you have voice problem in your menu options in your setting, please move to audio and video setting. and all you need is just to configure your audio settings. So you may need to dial over the voice over IP if you have a problem. But I don't see this is a server problem or from your side. So I think you can easily manipulate in your setting.
Okay, so I think most people are fine with it. It might be an individual case, so let's move on. Let me know if you were able to successfully install these libraries in your file. Head over to your files, run this cell, and let me know if you didn't run into an error. As long as you didn't get anything red in the result, we're fine. Okay, so I see for one person it's successful. I would encourage everybody else to also go and install these libraries and let me know if they are installed correctly. For most part, these libraries, these codes, they will be copy-paste thing for you. Once you get used to it, once you know the name of the library, you can always just paste it. You don't need details. Where should be installed? Well, you will, in the same copy. You have two copies. One copy that you made for later if you want to see something, and the second copy, which is the second file, which is for working now. So you can use one of these for later, whichever file you want. It's your choice. So pick one file to work for now and one for later. So the one you picked for now, just go in there and run the first cell and let me know if it ran without any error. So I see that now a lot of people said that it installed correctly, which is a good thing. That's your first step. Now you know how to install a secondary private virtual display for displaying the gym environment. The second thing is we now need to import some libraries. These libraries are entirely your choice. I would not restrict you to NumPy or TensorFlow or PyTorch. There is a lot of debate. What's the best reinforcement learning library for beginners or to get started? Is it TensorFlow? Is it PyTorch? Is it NumPy, Keras, Pandas? What kind of libraries we need? So for beginners, the ones like me who didn't know Python, I would say don't use any library. Start with vanilla NumPy. You can use just Python, you can use NumPy, you can use PyTorch, you can use TensorFlow. OpenAI Gym is written in a NumPy base, so it should technically work with any library that you want to use because most of them, they are written in NumPy base or they are compatible with NumPy bases. So if you're comfortable with PyTorch, OpenAI Gym works with PyTorch. If you're comfortable with TensorFlow, gym environments work perfectly with TensorFlow as well. And if you're new to Python and you don't know TensorFlow or PyTorch, I would recommend using NumPy. That's what we're going to be using in today's workshop. We will write everything in NumPy. So what should be our runtime type in Colab for this notebook? Doesn't matter. If you don't change any settings, if you just open the notebook, since we're not doing any heavy processing, we don't need any GPU, CPU acceleration, we don't need any extra power. So you can just open the notebook, leave everything default, and everything would be fine. Everything should work perfectly out of the box for now. So the computing libraries are basically entirely your choice. Pick whatever you're comfortable with. Whatever you have been doing your programming in, choose that and everything works perfectly with that. There's no right or wrong choice. PyTorch is more of Facebook, made by Facebook, or I think supported by Facebook. TensorFlow is more by Google, but they both have same functionality. The debate is TensorFlow better than PyTorch is like, it's just a personal opinion. They both have same functionality. They both give you exactly same kind of things. They give you same kind of simplifications that you're looking for. Or even if you don't find one in a standard way, you can always find alternative which is written by people. You can always head over to GitHub and, for example, there is something called TensorFlow Agents, which is which is very recent reinforcement learning library. Now there's no standard available for TensorFlow Agents in PyTorch, but there are many people who have already written alternatives to TensorFlow Agents for PyTorch. So picking the library of your choice is entirely up to you. You can always find everything in both. There is also TRFL by DeepMind. You're absolutely right. Why exactly we need to create an environment? Can we do all this without creating an environment? Okay, we are actually coming to that. The next topic after installing the libraries is exactly what we are going to discuss, like what is an environment, why do we need it, what is an agent. This is exactly what we're going to be discussing now. So go ahead, go to your notebook, run the second cell, which is just importing gym, importing numpy, importing random because we're going to be using it to generate some random numbers at some point, and importing matplotlib just because I like it. I'm comfortable plotting in matplotlib. I haven't really tried any other plotting libraries in Python. If you know any good one, please let me know. If there's any better or easier than matplotlib, please feel free to let me know. And then finally, we are importing the virtual display that we just created or that we just installed. So head over to your notebooks, run this cell, and let me know if it runs without any errors. Seaborn library is also very nice. Okay, I will actually try that. I heard about it, but I haven't tried it yet. I will actually try that. So let me know if you ran the second cell and if everything worked as we expected it. If there is an error, also let me know, because we will also discuss some common sort of errors that you might run into. So let me know if it's working. Worked for you, everything worked till now. Okay, sounds fantastic. The next thing is functions of environment and agent. What exactly is an environment and what exactly is an agent? This is the first question about reinforcement learning. First of all, I would like to know if you know what's the difference between supervised, unsupervised, and reinforcement learning. So let me know in the chat if you know the difference, what's supervised, what's unsupervised, and what's reinforcement learning. Or if you would like me to explain it a bit, maybe in 1 or 2 minutes, please let me know in the chat if you know the difference between these three, or should I go over the difference? Okay, someone said they know. Others, please let. Perfect. Okay, so it seems that everyone knows. I see one person who said, please explain. Okay, so in simplest possible terms, supervised learning, you have a large data set, you have data and you have labels, and you learn from it. That's the supervised learning. Unsupervised learning, you have the data, but you don't have any labels. So you mainly use some sort of clustering, or you use some sort of other method which doesn't require the labels for training. Whereas in reinforcement learning, you don't have the data and labels. You don't have the data, you don't have the labels. Reinforcement learning is another type of machine learning which learns from interaction. There are actions and there are rewards. Instead of the data and the labels, data and labels is the traditional machine learning approach, in which you have some features and you have the labels, and your goal is to basically teach the learning agent, that these features correspond to these labels. So over time, it learns to predict the correct labels. But in reinforcement learning, the agent learns to take the correct actions. It's more of a decision-making process. You have an agent, which is your learning agent. What if we have some data and we still want to use reinforcement learning? Okay, it depends what kind of data you have. If you have some data and you can convert it into the form of some rules of the game, if you can convert that data into the form of an environment, which I will explain shortly what an environment is, if you can convert it into an environment, and if you can define a rewards mechanism for it, then you can use reinforcement learning for it. The basics of reinforcement learning start with agent and environment. An agent is an actor. An agent is the person who is taking a decision, who is taking some action. And the environment is everything that surrounds him, everything that gives him a reward for doing the right action, or doesn't give him a reward, or gives him a negative reward or a punishment for doing the wrong action. So it's a lot like this. Please let me know if you can see this. In this figure, you're supposed to see, I think I need to make it, okay, I will move the chat to another box for now. I think now you can see my full screen. For the Facebook audience, I will make my figure smaller or move it somewhere else so that you can actually see what's on my screen. Okay, so in this figure, the agent is the dog, which is gonna take some action. Maybe it will fetch the ball, maybe it will spin, maybe it will roll over the ground. It will do some action in the hopes of getting a candy or a treat from the environment. So his environment includes everything that surrounds him, whatever gives him the reward. It can be an automatic treat setup, which gives him a treat for doing a certain action, or it can be a person, for example, the owner, who becomes happy with the dog fetching the ball and gives him a treat for fetching the ball. So the mechanism, the surrounding, which changes based on the agent's actions, is the environment. The environment also includes states. For example, the initial state can be initial time. The environment then moves to the next state, which is the next time. For example, some actions might be useful in some states, but might not be useful in some other state. For example, a kid doing a cute action when the mom is happy might get the kid some sort of candy or reward, but if mom is angry, she's in a different state, the same action might not get you a reward in that state. So the environment states matters for the actions in reinforcement learning. The same action in different states can result in different kind of rewards. So let me know if you understand a little bit. Please zoom out a little bit. Okay, I will. Let me come to the screen. So do you so far understand what an agent is and what an environment is? Agent is someone who takes the actions. Environment is something that gives rewards for those actions. So far, so good? If there is any question, please let me know. The details of act, update, functions, we will go into the details of it later. Like we will go into details of it now. So far, agent and environment, these two concepts should be crystal clear to you now, that agent is something that takes an render. We will go to render. Agent takes the actions, environment gives the rewards. That's the whole story so far. Now coming to the details of these functions and state and these things that we put on our screens. First thing we covered, what is an environment and what is an agent. Now the second thing is a state. I think I mentioned it a little bit, but let's go into a bit more details of a state. State can be time in case of some environments. State can be the mood of the person, like mood of the mom in another environment. If we take the example of some game, for example, the Atari games, then state can be whatever is on the screen. Current score, current velocity, current position. In case of a car, the state can be these things like speed, velocity, angle, turning, torque, this kind of things. They can be part of the state. So state is whatever represents the environment, whatever is changing in the environment with the actions of the agent. That is the state. If the agent takes the action, environment moves from one state to another state. That's a state. The next thing that we should understand is what is an action and what is a reward. So I think that's pretty intuitive. I would like you guys to explain to me, what do you think is the action and what exactly is the reward? Let me know in the chat, what do you think, what are your thoughts on what's the action and what's the reward? From the explaining that I did so far, what do you think counts as action? Action means decision by the agent, absolutely. Exactly. I think you're all right. So action is the action of the agent. For example, fetching the ball, or going left, or going right, moving forward, moving backward. So these are the actions, and the reward is whatever the environment gives in the reaction. Exactly. So this is, I'm so glad to see your responses. You're actually getting it very fast. So we can go a little bit faster then. So these functions, this is basically the drill. Now, this loop, these arrows, they are, once you master these, you master reinforcement learning. In every type of reinforcement learning, there will be this loop. In the beginning, there was nothing. Then came the initial state. So the beginning, the drill, to go over these loops, we need to see the drill a little bit. The drill, this is the most important part of this workshop. If you master this, if you need a sip of coffee, please take it, because we are coming to the most important part of the workshop. That's good. The drill. Remember this drill. Throughout this workshop, if you remember this drill, you can write the whole code. In the beginning, before we have started writing our code, there is nothing. Then there is the first step of the code, or first step of the reinforcement learning loop, is reset, which is this function here. Reset is a function of an environment. So it resets the environment to the initial state. It doesn't take any input. This side shows basically the input, and this side shows the output. The reset function is a function of environment. What does it mean to be a function of environment? Well, just like any object-oriented programming language, environment and agent are two different classes now. There will be some variables which belong to the environment class, some variables that belong to the agent class. And also there will be some methods, or in MATLAB language, there will be some functions that belong to these two different classes. So the first function of the environment class should be the reset. It doesn't take any input. I see some questions here. What's the difference between action and state? Action is the action of the agent. For example, left. For example, go right. For example, go forward, go backward. That's the action. State is a state of the environment. For example, if the agent takes the action go left, the environment, which is the setting of that agent, might move to time step 0 to time step 1. Or if it's a game, then the environment itself might move one step left. So the environment can have many variables as state. One of them can be time, another one can be temperature, another one can be, for example, the velocity, angle, this kind of variables that define the surrounding of the agent. So as a result of the action of the agent, environment moves from one step to another, from one state to another. For example, temperature can change from one time step to another one, or time always changes from one to another one. So it depends on us how we define the relevant state variables for the environment. Oh, the Apple example is really good. Good, you got it. You got it. That's awesome. So reset function doesn't take any input, and as output, it gives you the state. And that state is what state? That's the initial state. So we can define only time, for example, as our state. In that case, when we reset the environment, it will give us 0, for example, time 0 or t0 as the output. That will be our initial state. What do we do with the output of that function? We pass that output to the act function. Act function is a function of which class? It's a function of agent class. So agent class, this function takes this state as an input, and as an output, it gives what action the agent wants to take. So what does this function do? The act function, it takes as input what state I'm in right now. For example, I'm in time 0 right now, and what action do I want to take? Do I want to go left? Do I want to go right? Do I want to go forward or backward? Or do I want to fetch the ball? So the agent is going to decide on its action based on what state it's in. So it will take as input the state, where am I, see the surroundings, give the action that it wants to take as an output. That, okay, this is the action, this is what I'm doing. All right. So deciding an action comes from some sort of policy. We will go into the details of later, but the main point is the act function takes state as input, gives action as input, and that action is passed to another method of the environment. Method and function, I will be using them interchangeably. In MATLAB, we use the term functions, but in Python, the methods term is more common one. So I will be using them interchangeably just because I've used both languages for a while. What does act need in its input? Act needs a state in the input. This red arrow, it shows the state going as input to the act function. And as output, it gives action, which then becomes the input for the step function. Once the agent, the dog, has decided what it wants to do, it wants to fetch the ball. Okay, it tells the step function that I'm fetching the ball. This action, the action that the agent decided, becomes the input of environment's step function, because remember, environment is going to move from one state to another based on the actions of the agent. Sometimes environment may have zero effect from those actions, but sometimes it might entirely be defined. The next state might entirely depend on the action. For example, if your state variable is just time, then it doesn't matter what action the agent is taking. The environment is still going to step to the next time, from time 0 to time 1 to 2 to 3. It's going to move to next time step anyway. But if it's some sort of Atari game, or if it's some sort of environment that depends on the agent's action, then it's going to change according to the actions of the agent, just like an MDP. So the step function now takes as input action. And what does it give us as output? It gives us, in a standard format, 4 things. The next state. So if the initial state was time 0, it gives us time 1 as the next state. Or if the initial state was some XY coordinates, and now the environment is moving to another state, then it gives us the next X and Y coordinates for the next state. Okay, that's the first output. Next state is the first output of step function. The second output is the reward. In most cases, in most reinforcement learning cases, it's a binary reward, 0 or 1. Reward 1 for the action which is beneficial or good, reward 0 for every other action. It can be a continuous reward as well. In some of the reinforcement learning environments, we will see some continuous rewards as well. So it all basically depends on our own specific needs, is if our application needs binary rewards or if it needs continuous rewards. But in most cases, binary rewards are good enough. In some cases, we also introduce negative rewards when we want to discourage some sort of action. For example, if we don't want the dog to pee on the carpet, we will discourage it by negative rewards. Or if we don't want the car to crash into the wall, we will discourage that action with negative rewards. And the length and width of these rewards, for example, how high the positive reward can go or how much low the negative reward can go, also depends on the needs of your application. If the negative action is so bad that crashing your car is just going to destroy everything, then you put a high negative, you can put a high negative reward to that particular action. So defining which actions should have which reward is up to the programmer. You will define what's your environment and what are the rewards for what type of actions. That's one of the reasons reinforcement learning is called supervision through rewards or learning through rewards. It's still a form of psychologically supervised learning, but you're learning from the rewards instead of from the labels. You're learning from the better rewards you get, you start taking more of those actions, the actions that resulted in higher rewards, and you start taking less actions that resulted in negative or zero rewards. So this is teaching the agent to act in a certain way or take certain decisions by giving good rewards or higher rewards for some actions and giving punishments for different actions. As simple as that. Okay, what if, is it possible to set multi-agent to have individual rewards? Yes, it's possible, but we will go over it afterwards, maybe next time, or you can ask me later. I will answer in the details once we've covered the single agent. If the action involves risk, how do we model it? Well, if it involves risk, we give high negative rewards for it then. If we think that this action, the agent can take this action, we either exclude it from our action space, which is the next keyword that you should know about. Action space and observation space or state space. State space and observation space are used interchangeably. State space is normally used when you have a complete observability of the state, and observation is used when you have partial observability of the state. It's still a state, it's still part of your environment, but the more common term that we use instead of state is observation. Since we don't see everything in the environment, so we call it observation. Partial observation of the environment or partial observation of the state is called observation. Okay? So next state, reward, these two we covered. What do you think the flag done is? The flag done basically tells us if the terminal state has been reached. Done, the flag done is one if the terminal state has been reached or if one episode has ended. For example, if it's moving left or right in a state and the agent or the pendulum has reached the far right, the end of the frame, end of the screen, then we can say that, okay, the terminal state has been reached. So the flag done tells us 1 or 0. It gives us 0 in every other state except for the terminal state. The debug dictionary is an optional argument as an output of the step function. If you want to pass some debug info, if you want to say something, some detailed info as some string, if you want to give some warnings, you can pass them as a dictionary as an optional fourth argument of the step function as debug. So the single input of the step function is action. There can be, these are not hard and fast rules. This is a guideline. So you can always modify these functions according to your needs. You can add more inputs, you can add more outputs, you can skip some outputs. It's entirely up to you to customize the agents as well as environments as up to your needs. But this is just a standard gem structure. I will explain why we need gem environments or what's the purpose or use of gem environments anyway. So this is the step function. Next state, reward, done, and debug. These are the outputs of this step function. They are then passed on to something called update. Now, in this whole picture, where do you think the Q learning happens? Or where do you think the Q table, something which we say Q table, where do you think that happens? But what are your thoughts on it? Let me know in the chat. Where do you think the Q table is kept and updated? In this figure, you can point me out where. Yes, someone got, 3 people got the right answer. It's exactly in update function. So the Q table is maintained and stored and updated in the update function. What is a Q table? A Q table is just as the name suggests, it's a table which stores a Q value for every state and action. So on one axis, you have all the states. On the other axis, you have all the actions. So what would be the dimension of the Q table? What do you think in terms of any programming language that you've done, in terms of a matrix or in terms of anything, what would be the dimension or size of the Q table? Yes, states times actions, exactly. States times actions, because we have one Q value for every state action pair. So for every state, for every action, we have a Q value. But the
Sadia, sorry for interruption. Just wanna I'm curious to know if your screen is freezed or are you moving around? So can you tell us at which stage you are in terms of your screen showing?
I'm at the screen where I have a picture of agent and environment on my screen.
Okay, the same one.
Yeah,
Is
yeah,
that correct?
because
Can you scroll down to see if you're okay, perfect. So I just wanted to make sure that we are not
no, we are
frozen.
on the same screen because we are explaining the different
Yeah,
functions.
yeah, I
So
get
it's
it. I
gonna
get
take
it.
some time.
Just received a message from one of the guys. That's why I just wanted to
All
clear.
right.
Thank you.
All
Sorry.
right. Thank you for letting me know. So the update function is where we keep our queue table, and these are the inputs that the next state, reward, debug, flag, and this info. These are the things that we need to update the queue table. How we update the queue table is going to be the next thing. We will have an equation which will take this reward into account, and it will tell us which queue values we should increase, which queue values we should decrease based on how much reward the agent got in which state for which particular action. That's the whole story. That's the game of reinforcement learning. That's what makes it so efficient. That's what makes it so interesting to work with, that all we need is just the information, the history of in which state the agent took what actions and how much reward it got for it. In a way, Qtable is just a way of maintaining this history, that what was the state, what was the action the agent took, and how much reward it got. So as you see, this is how we as humans learn. This is how we learn from our mistakes and our behaviors. We see that what actions led us to something good and what actions led us to something bad. And our brain processes it in a way that we start learning to do good actions more, and we start learning to avoid the actions that led us to some sort of accident or some loss. So this is how we work. Q learning is just a mimic. It's just mimicking the behavior of us or our learning, right? So the last function here is the render function. Render function is an optional function. It does nothing but, as you see, it just takes input the delta difference, the update difference. This delta is basically just the difference of previous queue table value and the current value. It just tells us how much the queue table was changed in this particular iteration. And this render function just prints that information. We can print episode number, we can print how much accurate our agent is so far, we can print how much it's learning in the render function. It's an optional function. You can print it to see how your agent is getting trained, or you can entirely skip it if you want to make your process faster. You can just print everything in the end if you want. So this render function is an optional function. Now I would like to hide this from you and then ask you a poll question. I would like to ask my colleague to show you our next poll question. I would like to ask you about something we just learned. I would like to ask you which one of these, or how good you remember the drill, which one of these is not a function of environment? Reset, step, render, or update? Now, no cheating. Don't go back to your files. Don't see it from there. Try to answer it from memory. Try to answer it from what you just learned. Don't cheat. So, while you're going to the answers, I will show you now what's the purpose of GEM. What exactly is GEM? How it works? What's the benefits of it, or why we care about it in the first place? GEM is nothing but a collection of reinforcement learning environments. So we saw in environments that an environment is supposed to do certain things and have certain methods. So GEM basically provides you those methods pre-written. So I'm not going to mention to spoil the answer of the poll, but the GEM methods are already provided, the GEM environments are already created. They are pre-written codes that give you an environment, and the methods that are supposed to be part of an environment, they are already there in those GEM environments. Gym is basically created for practicing reinforcement learning. The purpose of gym is that you can write your own agent, your own learning agent, how fast it learns, how good it learns, how fast it converges. You can write and modify your agents, and these can be different types of agents. You can write a Q-learning agent or SARSA or policy iteration, value iteration, temporal difference learning, actor critic, deep reinforcement learning. You can include recurrent neural networks in it. So you can write any type of agent you want, and then you can test the performance of that agent on one of these environments. That's the beauty of gym. Since the environment functions are fairly standard and you know the inputs and outputs of these functions, so you can write one agent and test it on that gym environment. Then you can write another agent. As long as these inputs and outputs are compatible with each other, you can then use the same environment to test your other agent. So this way you can compare the two agents you wrote. For example, you wrote one Q-learning agent, you wrote one SARSA agent, and then you want to, for example, compare their performances on the same environment. So you can apply both of them on the same gym environment and test it. For seeing like some gym environment or to see the gym codes, you can just go to OpenAI Gym. When you go to OpenAI Gym, you see this tab called environments. I will zoom in. Oh wait, I'm zooming in the wrong place. So you can basically go to environments and see what environments are there. There are some game environments, some classic Atari environments. You can play around with them. You can create your agent, train it, see how good it plays the game. In that case, the environment is whatever you see on screen. That becomes your environment. So your actions define the next states. It gives you some rewards. Then you have some environments that teach you how to walk, how to not to fall, I would say. Then you have some classic control examples. These are some of the examples that we will be trying out today. Cart pole is one of the very classic problems in which you have to balance this pole on a cart. You have a pole on a moving cart, and you move the cart left or right to keep the pole straight. The objective is that you don't want the pole to fall. So moving it, your action is go left or go right. So you teach the agent to learn to go left or right based on the angle, the velocity, the position of the pole, which are part of your state variables. They tell you, okay, the pole is about to fall. Okay, what action should you take? You move left or right based on that to basically keep the pole steady or straight. Similarly, mountain car environments, pendulum environments, two-link robot environments, these are the classic control problems. You have some more exciting environments that need a bit more processing power, I would say. But yeah, you can teach them how to walk. Then you have some robotics environments. You have very, very exciting environments, and you can also submit your own environments. Once you have written an environment for a different application, you can submit it to OpenAI Gym, and it will become part of this list, this third-party environments list, where you will find all types of interesting environments. It's a long list, and you will have fun experimenting with these. So coming back to our workshop, have you answered the poll questions yet? If you've answered the poll questions, please let me know. Let's see the poll results if we have. I would like to see how many of you got it right. Intafab, do we have poll answers yet? If we have them, I would like to see them so that we know how good everyone knows the drill. Okay, we got the answers. Oh, wow. So almost all of you got it right. Awesome. So you're listening, you're not sleepy. Let me know if you start getting sleepy. We can always take another break. Oh, you're good. All right, awesome. Are you finding it interesting so far, or has it become boring already? Let me know if we are going at a good pace, because now we're gonna start typing a lot of code together. One last thing before exploring gym environments, there is something called spaces in gym. Sort of boring. Oh, I'm so sorry for that. I'm so sorry. I will try to make it more interesting. So, there is something called spaces in gym. Spaces is what we will use to define the action space and the observation space. Since we defined our actions, we need to define an action space. And it's nothing but a collection of actions, a collection of allowed or legal actions, the actions that our agent is allowed to take. For example, in case of a dog, we cannot maybe give an allowed action from jumping off the roof of the building. So we will define a set of actions which we will call action space, from which it can try some actions. This is sort of to restrict our agents not to take some arbitrary actions. And the same goes for observation space. In observation space, we will give a collection, a set of allowed states. If it's time, we will tell, okay, this is the initial time, this is the end time. Or if it's the frame of left and right in a game, then we will give the dimensions of that frame. We will give the coordinates of that frame, that this is the beginning and end of this particular frame. Okay. All right, let's close this. So you remember the drill. Now we are gonna see this drill in action. We reset the environment. We go to the initial state. That initial state, we pass it to the act function. What was the output of the act function? It was an action, right? So that action, we give it to the environment. From the environment, we get the reward. What function was doing it? It was the step function. That reward, but where do we pass that reward? We got 4 things from the step functions, right? So those 4 things, we pass them to the update function. And from the update function, optionally, we plot something by giving it to the render function. Okay? Once that's done, we go back to step 2. All right? So this loop repeats until our agent is sufficiently trained. Now, how we define sufficient training is also up to us. We tell what's sufficient training for us. Is it if the agent has had 90% accuracy in the past 20 episodes, then stop training, then we put that condition. Or if we say if the delta update, the Q table update is sufficiently small, it's not changing much, then we say the agent has been trained enough, then that's when we stop training. Or we can always define a fixed number of episodes. We can say, okay, I want to run my environment for 200 episodes or 2000 or 10,000 episodes and see what's the accuracy after that.
Yeah, I know that you are in a very sensitive situation. I wonder if we can give a break, because I see messages about break for 5 minutes maybe, not too much.
That's awesome. That's awesome.
What do you
Actually,
think?
everybody
Are you
should.
comfortable? Are you comfortable with break right now?
Absolutely,
Okay,
because
I'm gonna
we are
play a music. I'm gonna play a music.
perfect,
So
perfect.
okay. So let me see.
Oh, I see there's another poll also for the break for attendees. Let me know, guys, how much experience do you have with this after the break?
So I know that you and I can go back. Many words left unspoken. Some you and I have to know that another day soon will shine. And that will bring me all back. Your heart. There's no way I can breathe without you. And your smile makes it all so simple. This wall around your heart, cannot get through. You find fault, it's what you're searching. Down your walls, learn how to let go of your love. Fade away. What can I do? You and I have to know that another day soon will shine. That will bring it all back. Your heart and mine. There's no way I can breathe without you. And your smile makes it all so simple. This wall around your heart, cannot get through. You find fault, it's what you're searching. Down your walls, learn how to let go of your love. It'll fade away. Why can't we move
Okay, I hope everybody enjoyed. So I just hand over the presenter to Sadia. Sadia, please go on.
All right. I will close this and share the screen again. Also, I will go back to. Can you guys see my screen?
Yes.
Okay, perfect. Song is. Okay, are you guys back? Does Q stand for some meaningful word? That's actually interesting question. Please let me know if you find out the answer. I wonder why I didn't check. Please let me know. The scenarios without ending. No, you need to have a terminal state. Otherwise, you will be stuck in one episode. You move from one episode to the second only after reaching a terminal state. So if you don't have a terminal state, you're forever in one state. The question was that can we have non-terminal states? We keep going. Do we need to have a terminal state? So the terminal state is necessary to move from one episode to another, or you're gonna have to define another way to move from one episode to another without actually going to the terminal state. Then you won't use this flag, this done flag. You will find another way other than this to move from one episode to another one. So remember this drill. Keep it in mind. Let's do it now. So there is a common question that, okay, I don't want to work in Google Colab. It's difficult to debug in it, or bad internet connection, or I want to just work offline, or a lot of other reasons. So can I just use all this in a local machine? You can absolutely do that. You can install Gem the same way we installed it on Google Colab. You can install it locally, and you can do everything that we're doing here on your local machine. So let's go ahead and create our first gym environment. Let's get the first gym environment named cartpole1. You have this file, you can run this, and you can make this environment. Now this code block, it does nothing but this line here. It makes the gym environment. Are you able to see the font clear enough? If it's not clear, let me know in the chat and I will make it bigger. So once you have made the environment, we just reset it just for the sake of, right now we're not doing the Q table update or anything. We're just creating an environment and viewing it. Bigger, please. Okay. How about now? So we're just making an environment and using the tools that we just imported and installed. We are just rendering sort of this environment. We are taking random actions. Now the actions in the first cartpole environment that I showed you, cartpole environment is this one. Okay, let's open it again maybe. So if we go to the environments, the environment name is cartpole v1 that I'm importing right now. So in this particular environment, the action is just left and right, which is modeled as a binary action, as a 0 and 1. One of them is left, the other one is right. So if I can give action is equal to 1, or I can give action is equal to 0 to make it go in that particular direction. So if I uncomment this, to uncomment, you can just use control and slash. So like you can use this for, oh, sorry, this. You can use this particular command to quickly comment and uncomment a line. So I can comment the action that I was sampling from the action space of the environment, and I can just give my own action 1 or 0 to always take. And this is just some printing. I'm just calling the step function, getting the 4 outputs from it, then rendering using the render function. These are the built-in gem functions that I'm just calling to just sort of show what an environment looks like. So we're not doing anything here except just always taking action 1. So the cart will always be moving in only one direction, and I'm only running this for a couple of episodes. I'm not running it for a very long time, but in your own time, when you want to see how this action space works, you can always take action 1 or action 0, and you can run it for longer times to see. For now, what I'm gonna do is, there is a function called, when you make the environment, it already gives you some action space and observation space. We will go into details of that later. It also gives you a function called sample. So you can choose one of the actions from this action space. So for example, if the action space contains action 0 and action 1, what the dot sample function does is it randomly picks one of those actions. So it picks either 1 or 0. Or if the action space contains forward, backward, left, right, then dot sample function will randomly pick one of those 4 actions. So whatever your action space is, it will randomly sample one of those actions. So this was just sort of a copy paste code. You can find it in many OpenAI gym related environments. If you want to see another environment, for example, we can make a mountain car environment. So we just give a different name for the environment. Everything else remains the same. And we can just run it. So this time, just by changing the environment name, we just created a different environment, and now we are just taking some random actions and we are just sampling it. Same goes with other gym environments. So that's basically the benefit of using gym environments, that it gives you a standardized way of using environments. It tells you, okay, this should be your environment, these should be your methods, and these should be the inputs and outputs of those methods. So you can reuse the gym environments. That's the biggest advantage of using OpenAI gym environments, in my opinion. But I would also put this question to you, that what other benefits do you think are there for using OpenAI gym environments? Do you think, is there any other benefit for other than reusability for using these environments? Whatever you think, let me know your thoughts in the chat box and we can go over them a little bit. You can go ahead in your notebooks and you can render these environments. You can comment one or the other and you can try running them. You can see how they're doing. If you run into any sort of problem, you can let me know and we can go over them again. So take a few minutes, try to run them in your notebooks and let me know. Someone asked, can we create an environment and use? Absolutely, that's what we're going to do today. At first, we're going to just write our Q-Learning agent, which works with this predefined environment. After that, we will create our own environment and use the same agent on the environment we created rather than these predefined environments. If you change the number of iterations for this, what does it do in the drill? Well, it just runs the drill multiple times. If I give 10, it runs that drill loop 10 times. If I give 100, it runs the same loop 100 times. So it's basically learning more with more number of iterations. Error, name gym is not defined. Well, you need to run, I think your runtime, this is one of the most common errors. It means that you need to import gym again. You need to install and import gym again. So the first 2 blocks that we ran, you need to run the first one and the second one again, and this error will go away. Once you do that, it will absolutely be fine. It happens when your notebook has been maybe disconnected for a long time, or if you didn't run the first 2 blocks, or for some other reason. Sometimes the notebooks get disconnected due to some memory problems. So whenever your notebook gets disconnected, you need to run the installation and importing scripts again before you can use gym environments. I hope it works. Please try in your notebooks and let me know if there are any other errors or if everything works fine. Once you try, let me know in the chat if everything is working. Someone got previous screen error. That's also because you need to run the importing script again. For some reason, the screen did not get imported or installed correctly. So if you just run the first in sequence, the first block and the second block again, then everything should be working fine after that. Okay, so these are some of the very, very common types of errors that you will run into, and as a beginner, it can be a bit overwhelming. So I encourage you to search for help on this kind of errors, and you will actually develop a habit of searching this type of errors. You will get familiar with the forums or the places to look for the answers. One of the most common ways of getting help, as Faye mentioned on quite detail, are using help, using directory, going to the source code, or just Googling it. So OpenAI Gym has, it's open source, of course, and it has the whole code available here in GitHub. So you can go and look at the code behind everything. For example, environments, these will be wrappers, spaces. You can see what gym spaces are, what type of spaces you can create for your action space and observation space. The box type space includes high, low, data type. You can create a dictionary of your specific actions. For example, you can give a number and an array maybe. For example, you can say speed, and then you can give allowed speeds. You can say the action can have multiple things at the same time in the form of a dictionary. For example, speed or acceleration or angle. If you're driving a car, your action is not just, go left, go right. It can have an acceleration at the same time as changing direction. So you can create a dictionary with that type of actions. So you can give whatever you want to be part of your action space. So spaces is a way to create action spaces and observation spaces. Spaces is a way to give a collection of actions and a collection of states or observations. States and observations, I will be using them interchangeably. So this is a way for you to give states and actions that are allowed in your environment and your agent. So you can create a dictionary, you can use discrete action spaces and observation spaces. There are some other types, multi-binary, multi-discrete. You can go into their description for more details. Once you're more familiar with the action spaces and once you've gone past the initial smaller or kind of, baby steps of action spaces and observation spaces, then you can go into different types of action spaces, observation spaces, and you can explore them. You can also go to GitHub and see the codes written by other people. It's always very simple process. You can just Google, for example, mountain car deep Q-learning GitHub, something like that, or anything that comes to your mind, anything that you want. And you can open the GitHub links, you can see what they have written, how they're doing it. You can see how they're organizing their code. That's how I learned how to organize my code. It was from GitHub. I saw that people were using and reusing their codes by organizing it into folders. They have one folder for environments, one folder for agents, another folder for memory, another folder for policies. So every time they are writing a new code, they just import an old file with it and make modifications that they need. For example, I can import another environment from the environments folder, another agent from the agents folder, and I can then use them together. So use, reuse, and reuse your codes. Don't waste your work after using it one time, after writing your code. Don't just leave it behind for, forever. Reuse this code again and again, build on it in your future versions. So as Faye mentioned, whatever function you need elaboration on, you can run, for example, help, or you can run directory, and it will give you some sort of basic information. But if it's not clear, you can always just go to Google and you can write help with this gym function, or any sort of question. For example, what does step function do in reinforcement learning? And it will give you more information about that. This is just another way of opening help. This is also, as Faye mentioned, another list of things that you can do with certain things. So what if you need to do some environment specific tasks in your code. For example, you want to get some information from the gym environment. You created the environment. The way to create a gym environment is just by environment name. All of the existing environments, you just give environment name. You say gym.make and you give the environment name and it makes the environment. Now in env, you have everything available. The things that you can do with env, you can find them with directory env. So for example, you know here all the things that you can access. You can do render, you can do reset, you can do step, you can close the environment, you can find the action space. For example, let's see the action space of this environment. Let me create a code block here. I can say env dot action space dot sample to see one of the actions that it samples. To run this block, you can just enter Control Enter. It gave me action 0. Let's run it again. Action 2, 0, 1. So it seems it has a discrete action space of actions 0, 1, and 2. And they might correspond to different things. So whenever you want to see more details, just run a couple of times or just get more help on the function. If you want to, for example, print the environment name after creating it, you can unwrap the environment, and from the specifications, you can get the ID of the environment. For example, if you're writing a code and you want to do one thing for one environment, but another thing for another one, you can put conditions in your code, like, for example, if cart pole is in the environment name, then do this. If mountain car is in the environment name, then do something else. There can be minor differences in gym environments itself. For example, one environment can have discrete state space, or another environment can have a different type of state space. So you can write this type of conditions so that your same loop, one code, works with all type of environments. So this kind of conditions or unwrapping environment specifications will help you reuse your codes. So far, so good. Let me know if you have any questions. Take your water, take your coffee, and let's write codes now. What is observation space? Observation space is basically your state space. The terminology state space and observation space is used interchangeably. State space, when you have full knowledge of the environment, when you know everything there is to know about the environment, and observation space, when you have partial observability, when you know a couple of things, when you know maybe time and temperature, but you don't care or don't know the humidity. So we use the term observation space more often to define the environment variables, things that are changing in the environment. Those are our observation space. Why did we choose random action from agent? Don't we have to do actions based on states? Exactly. We chose random actions because we just wanted to see how an environment works. How does it look like? We haven't started teaching anything to the agent yet. We just saw that if it takes the random action, then this is the kind of action it will be taking. And now we will start teaching it how to take the right actions. So let's write our agent now. For someone who said it's not working now, please go back to the copy that you originally made and try to run that one maybe. This is why we use 2 copies. So if it worked first time, you might have made some sort of changes accidentally or some indentation left and right, which is making it not work now. So you can either go back to GitHub and clone it again and run it again, or you can go to your own second copy, make another copy with it and run from there. So always have a backup plan, always back up your codes, have a version control system always. The essence of Qtable. What do agents do? Agents take an action. What functions an agent will have? there were, if you remember, how well do you remember the drill? What were the functions of an agent? Don't look at your notebooks. Let me know in the chat what are the actions, what are the methods that belong to the agent class. Very good. That's awesome. That's awesome. Very, very good. So you are with me. You are learning with me. To do those, the most important function is the update function, in which we will update the Q table. Now this equation is from the mother of reinforcement learning book. This book is literally, it has everything you need to know about reinforcement learning. This is how we will update our Q table. Now Q table has 2 dimensions. Name base is not defined. You need to import base 64. Just write import base 64 and then try to do it. So QSA, QST and AT. ST represents state, AT represents action, and T represents time at that moment. So Q value of this state at that time and this action, by this I mean a particular action, at that time is updated as the value that was plus alpha, which is a learning rate, times the reward that you got, RT plus 1, plus gamma times maximum of Q value of the next state. Time here represents my state, or T plus 1 represents my next state. ST represents my current state. ST plus 1 represents my next state. So maximum of Q value of next state, initially they will all be 0. So we get these values, we subtract our current Q values from it. So this is basically just the Q table update. We just follow it as is. This is how Sutton and Barto book tells us how to update your Q table. This is Q learning equation. It's based on Bellman update. There are proofs why it converges, how fast it converges. If you're interested in those, you can just Google convergence of Q learning or the math behind Q learning, and you can basically go over them. But for now, this is the equation. We will write our agent with it. So let's create a class called agent. I think you have this already with your file. Don't run this file yet because it has some missing pieces, missing codes that we will be writing together here now. So what we want to do is see what parameters do we have in this class. We have the learning rate. We have the gamma parameter that we will need here. Learning rate is this alpha. Also, we have action space. We have observation space. We have number of episodes. We have observation space length and action space length. These are just, what's the difference between small and s? I think that's just a typo while I was writing this. It should be, I think, big S here as well. There's no difference. It's just a typo on my part. Thank you so much for noticing. So we just create these parameters that we got as an input to our agent class. We just assign them in our initialization. In the Q table, notice what we're doing. We're just initializing it randomly. You can initialize it to zeros, you can initialize it to random numbers. It doesn't matter. You just need a table. It's a common practice to initialize it to zeros as well. So if you want to initialize it to 0, you can initialize it to 0 as well. And the size of it will be your observation space times your action space, because we will have, remember, we will have one Q value for each state action pair. Okay, so we are initializing our Q table randomly here. There is another parameter called epsilon, and we will talk about it at the end of this workshop. But for now, remember that epsilon is something which is used to balance exploration versus exploitation. Exploration versus exploitation means that should I take a random action in this state to know that I might get a higher reward, or should I take the action which has previously given me the highest reward? For example, if spinning around gave the dog a treat, next time, should the dog just spin, or should it try to go fetch a ball if it hasn't done that before, hoping that it might get more treat for that or higher reward for that? So this dilemma of balancing, should we take just the actions that gave us previous reward, highest previous reward, or should we try a new action from the action space? It's called exploration versus exploitation dilemma in reinforcement learning, and epsilon is one way to balance it. It basically tells us that, okay, take the best action, the action with best reward with a certain probability, and take a random action with a certain probability. And this probability is changed throughout the training. In the beginning, the probability of choosing random actions is more, but as the training progresses, the probability of taking random action decreases, because we expect that now we have learned enough to know that, okay, the actions that generated the best reward are actually the best actions. As the training progresses, we are assuming that we have tried all actions enough times already to know what was the reward for them. Okay, so far so good? Still not working. Should I just carry on? Yes, please carry on. Just copy the file again from GitHub and try to carry on. Try to follow as much as you can, and we can fix some problems later then. Let's write the act function. Now, let me know in the chat, what were the inputs and outputs of the act function? What does it take as input, and what is it supposed to return as output? Let me know in the chat. I'm reading your chat now. Input state, output. Oh, now we have different opinions. We are getting some people are saying reward. Remember the drill. Remember the drill. Okay, go back to your notebook, go back to the drill, go back to the picture that we saw before, and then let me know the inputs and outputs of this function. Okay, perfect, Paul. Yes. Okay, it seems like most people now got it. So what does this first line? Now this is the part where you will write the code with me here. Read the comments. It says this is the function that takes the observation as input, and I have also given it as an optional action, as an optional element input, the episode number. If the random number that we generated is less than epsilon, which basically means that with this certain probability, return a uniformly sampled random action from action space. How would you do that? If you just want to sample a random action from action space and you want to return it, how would you do that? And the second line here, this one says return the action that has the highest Q value in state observation O. Now remember, our Q table already has some values. Our Q table has a dimension already, it exists. So we can do that. We can do the argmax, or we can do the max operation here. So these two lines, first let's focus on the first one. Try to write it. How would you do that? How would you return a uniformly sampled random action from action space? We've done that before. That's a hint. randoms function, that's very good option. It's very, very good option. You can do that. Try to go over the notebook and the question. Yes, someone actually got, wow, more than one person actually got the exact right answer. Yes, yes, you're doing very good. You're actually doing really, really good. Exactly. To return a random action from our action space, we can use the dot sample function. So let's do that. We can return environment dot action space dot sample. Now there is a mistake in this code. This is what most people told me so far. Now, when we are writing it inside this class, there is a little bit of a mistake here. What's the mistake? Yes, someone got it. We should use self because we passed the environment section space to this function as we passed it as an input to this class, and we already have it in self now, self.action space. So we can use self.action space.sample. First part is done. Second part, which will take you a little more time. Return the action that has the highest Q value in this state observation. Now let's try to do that. You have the Q table here. This is the Q table, self.Q table. It has a certain dimension that you know of. You know current observation is O. So you want to return the Q value that you want to return the action that has the highest Q value. Now remember, Q table has states and actions. On one dimension, you have all the states. On the other dimension, you have all the actions. So you first want to go to the relevant state, Q table of that state. Once you have that, then you want to know in that particular row, which action has the highest Q value. Or basically you need to do an argmax operation to know which action has the highest Q value. So you will return that action. Since it has, Q values for each action, you will return the action that has the highest Q value. Try to do that. Think it over, take a few minutes, and try to come up with some answers. Let me know in the chat, then we will proceed. Basically, Q value is the reward for corresponding action. No, it's not the reward, it's the Q value. It corresponds to the reward, but it's not the reward itself. It's a value that changes with reward. It increases and decreases in each episode. It's not the exact reward, but it's proportional. Someone got the answer very close. Very, very close, but not quite right. Yes, we will use argmax operation. We will use np.argmax. Or if we are using max, then you will need value and index. And index is the one that we will use. Yes, size of Q table is correct. Second parameter, we won't use it in this particular equation. The episode number, it's only to balance exploration and exploitation, and I already used it wherever I wanted to use it. Yes, now I see like people are starting to get it. A lot of people actually are getting it right. The common mistake is that a lot of people are suggesting, this is what a lot of people are suggesting, np.argmax of self.qtable. Now, I would like some of you who got the right answer to point out the mistake in this. This one is the most common answer that I got so far. There is a little bit mistake in it. What do you think is the mistake? Yes. So a lot of people now, after this, got it. We need to go to the corresponding observation. There are multiple ways of doing it. This is just one of the ways. You can explicitly define the the axis. You can use just the max with axis is equal to 0. So there are multiple ways of doing this. It's just a matter of syntax. This is just one of the ways. But yeah, this is the value that we are looking for. Paul, again, qtable, argmax. Argmax is what gives us the argument that has the highest value. For example, if you have a qtable, it has only two values. The first box is, let's say, 10, the other box is, let's say, 20. So argmax is a max operation over this, but it tells us the index, the place of the maximum value. So argmax tells us, okay, this location, the box that has 20, it gives us the location of the box instead of the value 20. So here we're not interested in the maximum Q value. We are interested in the action that gives the maximum Q value. That's why we are taking argmax. Okay. So did you all get this so far? By writing self Q table of O, we are going to the row of the Q table. Q table is a table. You can visualize it as a table. It has rows, or you can say the first axis corresponds to the states which are represented by O's. These O represent those states or those observations. And the other axis, the other dimension, represents the actions. So first we go to the corresponding state. So if we have two actions, we will have only two values now. And we want to see which one of these is bigger. And we want to choose the index of the bigger value. I hope it makes sense now. We are dealing with a table. We are dealing with a two-dimensional array, if it makes sense to you. Or in MATLAB terms, we are dealing with a matrix, a two-dimensional matrix. The values correspond to rewards. They change with rewards. We will see how they change. They are not exactly the rewards as is, but they change, they add, subtract with rewards. We multiply and add, subtract rewards with something to actually change them. So far, so good? Okay, let's write our final function now. The update function. Here we are going to implement the equation that we just saw. The equation was old Q value plus learning rate times the reward plus gamma times maximum of next state's Q value minus current Q value. So this equation is something that we're going to implement. Let's try to do that and let me know what do you think. First thing, what's the old OA value? We want to store old Q value here. How do we do that? Old OA means just whatever the Q value is at this particular O and this particular A. Update function, always remember the drill. Update function, what does it take as inputs? O, A, R, and next state, next observation, O prime. We call it O prime here. What does it give as an output? It gives the difference between current Q table and the updated Q table. How much the Q table has changed in this iteration. So we need to know the old OA value, which means old just means current. Old just means whatever we have before the update. So before we update the Q table, what's the Q table value for this O, which we got as an input, and this A? How do we access it? How do we get this value? Let me know in the chat. It's very easy. where do we have qtable? We have it in self.qtable, right? From self.qtable, this is the entire qtable. We want to get qtable of O and A. Now this is also another just matter of syntax. There are multiple ways to do it. So depending on the programming language of your choice, depending on the libraries you want, there are multiple ways of doing it. This is just one of the right ways of doing it. Okay, so we got the old OA value. Now we want Q prime value. Q prime, what do you think Q prime is from O prime? From this description, estimate of the optimal future value or maximum Q value in observation O prime. What do you think Q prime is? What comes to your mind from the word? No, Q prime is not the new Q value. From the description, we see that it says Q prime is the maximum Q value in not the observation O, but the observation O prime. So Q prime is still a Q value. So we know it's gonna come from the Q table, right? It's gonna come from there, but it's the maximum over all the actions. It's coming from O prime. Now this part, it gives us the two Q values in O prime, right? And we need maximum Q value here, not the action that has maximum Q value. Q prime is the maximum Q value in the state O prime. So how do you think we can find the max of this? Do we need argmax here or do we need just the max? We want Q value, not the action that has maximum Q value. So what do we need here? Just the max, absolutely right. We just need the max. And that's it. That's all. Now we have the old OA value, which corresponds to this value in this equation, old OA value. We have alpha, we have reward as input to the function, we have gamma. Now max over Q in the next state over all actions, this is Q prime, right? This is exactly what we did. We went to Q table in the next state, O prime state, and we took max over all A's, max of Q. So we have the Q prime, this value, this term. We also have this term that we needed before, right? So can you write this equation from these values now? O underscore A and O prime variables are a bit confusing. Can you redefine these terms? Okay, which one's O underscore A? O underscore A is not a variable. O is observation, A is action. So when we say Q underscore O underscore A value, we just mean Q table of this observation. S is O. Remember in your mind, state is observation. So Q of this particular O and this particular A. That's what OA means. Got it? And what was the other thing you asked? Can you ask again, please? O prime. O prime is just, this is if ST is O, then S of t plus 1, next observation is O prime. Current state is O, next state is O prime. All right? Does it make sense? Okay, perfect. Alpha is the learning rate, absolutely. Alpha is the learning rate. So we have alpha in self.lr. We have gamma also self.gamma. So we have all these terms now. Let's write the equation. Okay, we have our first answer for the Q table. I'm sorry if I'm saying the name wrong, Siraj. Your Q table equation is absolutely right. It's just missing some indices. We don't want to update Q. When you say self.Q table, we mean Q. We want to update Q only for this S and this A, or only for this O and this A. So your equation is only missing the relevant indices. Let's write this part, only this part first. Let's call it, normally this term from here to here is called TD target in reinforcement learning terms. So we can say here, we can create something called TD target, and we can try to implement only part of this equation, this part. So it's reward plus gamma times Q prime, right? So we can say here, reward, we have it as R as input to this function. So we can just say R plus self dot gamma times what do we need here? We just computed it. This value, what did we call it? Yes, we called it Q prime. Do we need to put self with Q prime? Why and why not? Okay, perfect. So far you're following perfectly because it's a variable of a function. Absolutely. Now, since we have this term as TD target, this part, can we implement the rest of the equation? Okay, absolutely. Go ahead. Let's write the rest of the equation. Absolutely. Someone already got it right. Someone already got it absolutely right. So I'm just gonna do exactly what we said we will do in this equation. Self.Q table of what values? O and A. This is what we want to update. And since in Python, it's a matter of syntax, I can do plus equals for self addition. So I can write it like this. Then I can do self.learning rate times. Now, what are the values that I need here? After the alpha. My alpha is here. This is my alpha. This is the term I already computed. What did we call this term? We said this term is called TD target. TD target. What's the other term? Minus old, what did we call it? Old underscore OA value. So self.Q table is now complete. What do we want to return? We want to return the difference of the new and the old Q table. So what can we do? Now our new value is this, right? And our old value, we already have it. This value minus our old value. Did everyone get it? We have our agent class complete now. Environment, we already have it from gem. So now we can run this particular agent on this particular environment by writing the loop that we said we will write, the drill that we discussed. Are you ready for that? Okay, let's do it. Let's run this class. Did I run it? Let's run it again. Okay, we have our class ready. The next function is just for discretization of the environment that we are using. For now, you can just use it as it is. If we find time at the end of the workshop, I will explain what it does. In simple words, it just discretizes some states. Let's try to create the agent that we just made. Let's try to pass some values for learning rate, gamma, action space, environment, everything that we just said. And let's try to print the shape of the Qtable. Do this step and let me know if you're getting the same shape for Qtable as I just did. Error agent is not defined. You did not run your class agent. The block that defines the class agent, you didn't run it. Or it resulted into some error. Okay, everybody else got the same shape. Wonderful, wonderful. Let's go to the next step. Now we need to write a loop for training the agent. Error namespaces is not defined. The same thing, your runtime got disconnected. So in the imports, when we imported gem spaces, you need to run that block again. Basically run everything from the beginning until this point, and it should be fixed. Can I show the code I wrote again? Absolutely. So these are the lines that I just wrote. The act function and the update function. What I will do is I will update this. Save in GitHub. So that you can actually access it. In case you are running into some errors, I've updated the file, the GitHub file that you already have the link to, you already have access to it. And this error is very common. You will run into it multiple times. So just keep reloading until you get the file. So all the changes that we've made so far, you have them in the GitHub file now. Could I see update Qtable based? I think you mean Qtable update equation. So here it is. I will leave it on the screen for a couple of minutes for you guys to follow. Also, we have the next poll now. And I'm pretty sure all of you are going to get it right. Which one of the following is the correct sequence from the drill? Always, always remember the drill. So is it act, step, update, act, update, step, step, act, update? And as I mentioned before, no cheating. Let me know if you guys feel super tired and if you want to take like a 5 minutes break. Someone found a cheat. Someone asked Qtable is always two-dimensional matrix. No, it depends on the size of your action space times your observation space. So if your action space is one-dimensional and your observation space is one-dimensional, then Qtable is two-dimensional. But if they have more dimensions, if your action space itself is three-dimensional and your observation space is two-dimensional, then it's like 3 × 2. So the dimension of Qtable always depends on the dimension of your action space and observation space. Okay, a little break. All right, so before we start writing our loop, which is the final part of this workshop, let's take a 5 minutes break. Until then, feel free to get a coffee, get this updated file. If you're running into some errors with your own file, you can get the latest one from GitHub again. Action space is not simply the list of allowed actions. How can it be multidimensional? Yes, it can be multidimensional in a way that, for example, if your one action in driving the car contains the angle that you want to divert to, the speed at the same time that you want to increase or decrease. So your action space can be multidimensional in the way that it has angle and speed. So they are both the variables that are changing at the same time. So you have allowed speeds in your action space and you have allowed angles, allowed directions in your action space. Right? Make sense? Well, Qtable is automatically created from, someone asked about the size of Qtable changing with size of action space and observation space. Since Qtable is already created from action space and observation space, the size will change automatically with it. Sometimes you might need to make some adjustments to it manually, but most of the time it will take care of it. Let's take a 5 minutes break. It's 12:40. We will come back at 12:45. Take your coffees. Feel free to ask your questions in the chat, and I will take a look at them again in 5 minutes. So, hello everyone, are you back? I hope you got your water, coffee, whatever you're drinking right now. And let's write our training group. Let me know in the chat if you've answered the poll. Let's see what are the poll answers. I'm sure all of you got it right. Let's see if we have the poll results by now. Yes, we have the poll results. Yes, you got it right. Okay, so moving on, let me just open chat in a separate window. I would like to verify if there is a, oh, I see you have a bunch of questions here. Unexpected indent. If you have any indentation errors, just use the latest file that I uploaded in GitHub. It's very common, it's very normal to have some indentation errors. It's not a big deal, it's okay. You'll get better with time. It's all right. You would like to verify there is a difference between reset and state function. I understand that the prior is only called one, but I'm asking in relation to the poll. Step and reset function. Well, step function, they both have same output. They give you the next state. The reset function is called at the beginning of every episode. We will do that in the training loop now. Whenever a terminal state has reached, we go back to the initial state. Whereas the step function just moves the environment from one state to another until the terminal state has reached. After the terminal state, we reset the environment back to the initial state. It's a very good question. All right, so if there are no other questions, let's move on. I'm sorry, I'm not really looking at the Q&A section. I hope somebody is taking care of the Q&A section. Due to the limited screen space, I am only seeing the chat right now. So if you want to ask some question directly to me, write it in the chat. Or if you have some question which you need detailed answers to, write it in the Q&A section and somebody from the team will help you with that. Okay, so far so good. We created our agent. Do you see my screen clearly, and is everything working okay for you? Also from the team, can someone check if everything with the stream is also going well? Let me know if there are any problems. I will keep my WhatsApp open on the side, and let's finish everything together. So the main loop for training is easy to figure out. We will start by
Sadia, you need to share your screen.
oh, sorry. Let me share it again. Okay, can everybody see my screen?
Yes.
Thank you, Mansoor, for letting me know. All right, guys, so let's start with some parameters that we are going to use. Remember, when we created our agent here, we were passing these parameters manually: learning rate, gamma, action space, environment space, everything. So we can just write them here at the beginning of our training loop. The environment that we are using from Gym is called CartPole, and it has discrete action space. Like, the action space is not one-dimensional. It has position, velocity, angle. So it's a multi-dimensional action space. That's why we are sort of, and it's continuous, so we are manually discretizing it. For now, you can just copy this part as it is. I think you already have it in your codes. You can ignore it for now. We will go into the details of it later. And the same thing goes for the CartPole environment. Since we need to discretize it, we are creating different observation space length and action space length. Action space length will be the same. We are just getting it from the environment itself. But observation space length, since we are discretizing it, we are giving something relevant, something specific to the environment here manually. It wouldn't be a big deal once you start getting used to the reinforcement learning environments a lot. Just like we created our agent here in this test box, now we are actually creating it again here using the parameters that we just defined. We defined how many episodes we want, what should be the learning rate, what should be the gamma. After defining these, we are again just exactly like before creating the agent. After creating it, we are just rendering it once to see. We also created some parameter called display every, which means I just want to display it every 100 episodes to see what's going on with the environment. Okay, so far we haven't started the actual thing. The else part is for another environment. Once we want to use the same code on another environment, we will be using the else part. So you can ignore it for now. You can create flags like show verbose or render gym if you want to see the training, or if you want to. Just for now, I'm gonna choose show verbose. We can keep it false, but render gym, I'm gonna change it to true. And I'm gonna reduce number of episodes, because if I run it for the whole episodes, it will take forever. So I will create number of episodes. 10,000 is okay, maybe. Might not be too much. Then again, we are creating some variables in which we are storing our accuracy or our delta, whatever Gym environment returns as a performance indicator. To store them, we are just creating some other variables. This is where our training loop begins. for episode I in range number of episodes. Now you can create a while loop like until done or until this much accuracy reached or any other type of loop. It's totally up to you for how many iterations you want to run your loop. So I'm running it for 10,000 episodes. The first step that we need to do after just initializing our parameters is remember the drill. What's the first step at the beginning of the episode? What do? We reset the environment and we get the initial state. We get the initial observation O. So let's do that. Our O is equal to what? env dot reset. Is everybody with me so far? Let me see your answers. Yes, everybody got it. Everybody says V reset. Does reset function take any arguments? Do we need to give any arguments to the reset function? No. So that's it. This is all we need to do. We just get O from the reset function. That is all we needed to do in this code block. That's it. What do we do after the reset function? This is now the environment has been reset, and now this part, the if part, you can ignore it. This if part is just discretizing that state that we just got, right? While not done. Well, this basically means this done flag is the done flag that we are getting from one of the functions. Which function is that? Which function gives us the done flag or end of episode or terminal state flag? Which function is that? Let me know in the chat. There is a function that we have. There is a function. You can look at the picture that we discussed and you can tell me there is a function that gives us 4 outputs: next state, reward, done, and a dictionary. Okay, yes, all of you got it right. This is the step function. Step function gives us the flag done. So this done flag, while not done, this flag we set it to false somewhere. Done is equal to false. We are starting with done false, that it's not done. So this while loop will run until the terminal state has been reached. Now, what does the first thing say? The first thing here, the first comment tells you call the act function. Remember the drill. What's the first thing we do after reset? We call the act function from the agent and we get the action that the agent wants to take, right? Because the act function returns the action, right? And when we wrote this function, what were the input arguments that we gave to the act function? Call this act function and let me know in the chat exactly in the exact syntax how you would write it. Let's see. So far, I haven't received any answers. Okay, someone called the function correct, but it has to have an output, and you have to store that output somewhere. It returned. Yes, somebody got it almost. Okay, someone got it perfectly. Okay, so you're all doing right, and at least along the right lines. So the output is A, the action, right? We are calling it where? On which class? Is it agent class or is it environment class? This is what most of you, I'm seeing in the chat, most of you are missing it. Which class? Agent class. So agent, where is agent? Agent.act, and it takes input what? This already tells us here that it takes O. So we can say O is equal to O. And it takes as argument episode I, which is equal to, we called it the same thing here in our loop. I hope the spelling, we kept the spelling same. Yes, we kept the same. All right, so far so good. Let me know if there is any confusion so far. We got the action from calling the act function. All right, what's the next step? We need to pass this action to which function now? Yes, agent with capital A is for the class and with small a is for the instance of the class that we created here, agent. Remember, keep in mind the capital one is for the class and the small a is for the instance of that class that we created. After act, which function do we call? Some of you are getting it right. Yes, we call the step function. To call the step function, what does it return? What does it give as output to us? It gives us O prime, next state. It gives us R, it gives us done, and it gives us a dictionary which we didn't pass, so we can put an underscore there since we are not getting an output from it. Okay? So this function is a function of which class? Environment or agent? Environment or agent? Environment, that's right. So environment dot step. What are we passing to it? Action that we just got from the previous step. We called it just A. Or we can say the full form. We can say action is equal to A. So far, so good? Let me know if you're with me. Write that down, write this down in your notebooks, and let me know when it's done. If there are any questions, confusions, let me know. Which function do we call after the step function? Yes, we can just write A. Yes, exactly. We call the update function next. Absolutely right. This step you can ignore the cart poll. This is just for the discretization. Whenever we are calling, you will notice whenever we're taking an observation, if the environment is cart poll, we are discretizing it. That's all. This is the only difference for cart poll environments. It won't be there for other environments if the environment already has discrete observations. So we call the update function. This update function takes as input O, A, R, O prime. So we pass these arguments to this. And we created an empty list here called delta update. So the delta update that this function returns, we are just appending it to that list. You can have another syntax. You can store it in the form of a NumPy array or whatever form you like. So we are calling this delta update function. After updating it, now there's no function in the drill that we call. We have reached all the functions that we wanted, but there is one very, very important step. If you miss this step, you will kind of lose your progress. What's that step? The environment, we did all the act, update, step, update, sequence. Now the environment needs to move from one state to another, which means our current state has become our next state. Reward part, that's done. Reward, when we took the step function here, someone is mentioning about the reward. When we did the step function, it already gave us the reward. All right. So this part is already covered. Now we just need to move the environment to the next state. Our O becomes O prime. Let me know if you have any confusion about this part, or if you're with me so far. Are you with me so far? If there's a confusion, let me know, because this step is very important. We are telling that whatever our O prime was due to the section, now our O has moved to that. We are kind of moving the environment from one state to the next. If the time was 0 before, now it's 1. If it was 1, now it's 2. This is what we are doing. Are you following so far? Yes. Thank you. Thank you very much. All right. So basically the next part is just sort of plotting it, showing it, storing the values, the delta value, the reward value, things that we need to store for plotting how our accuracy is changing, how our training is progressing. So basically we've written all the important parts that we needed to write. We can just go ahead and run this. And we have some sort of error. Oh, mountain car environment. We don't want to run it on mountain car environment. We want to run it on cart pole environment. Because this is because of the discretization step. Let's change our environment to the cart pole. Let's go ahead to the first step. Either we change it here or we can change it separately also. We don't need to run the whole thing, just where we created our environment. This is the agent, it remains the same. This is the environment. So before this, we create a code cell. We write this, we say environment name is equal to cart pole, because we want to run this environment on cart pole environment since we included the discretization step. So as you can see, this is running. Did we create the environment before it? Okay, I'm gonna stop the training for now just to make sure that we created the right environment. This is just the environment name. Creating the environment part was something we did before. So let's create this environment here so that we have the cardboard. The session crashed. This is something which will happen a number of times to you. Whenever this happens, you need to run all the steps that we ran up to the current step all together. To do that, you can do exactly what I'm doing right now. You can go to runtime and you can say run before, or you can press Ctrl F8. What it does is it runs all the cells until this cell. So I want to run all the cells until this cell and then run this one manually. I want to make sure there are no errors in the previous one. Okay, it looks like they all ran correctly. Now we can run this one. Okay, now we have the right environment. It's learning. Once it's done learning, we can plot some accuracies and some matrices. And Faye already showed you how to make the plots look fancier, how to use different markers, how to use figure sizes. So use all of them, especially when you're making some figures for scientific publications. It's always a good idea to use different line types and line markers Maybe not the line colors if you want to save on, colored publications, but markers, line types, ligands, these are very, very good options to actually make your figures look clear, crystal clear for the scientific publications. I'm not sure if you noticed, there are multiple options to download your figures. You can download them in PNG form, in vector graphics forms, in EPS forms. So if you're making figures for scientific publications, I would recommend using the EPS format. Let me know if you have any other format which is your favorite, which you find better for scientific publications. For now, I'm using EPS. If is also uncompressed and another option. I think, yes, I think you're right. You're getting an error in assertion in environment.step. Environment.step should not have any assertion. If there is any assertion, you can comment it out. If you have a custom environment, you can basically just, still you will have environment.action space, environment.observation space. So from there, you can pass their sizes. Okay, for some people who are running into some errors, I will save the latest copy in the GitHub so that you can access it. The errors that you're getting are pretty common. Some of them will be assertion errors, data type errors. Sometimes you explicitly need to give some types. Yes, this will override the previous copies. So that's the thing with version control. You can still go to history and find previous copies. If you go to histories, you can find which version you want and you can open it. So latest version right now is this one. You can go see previous versions as well. You can see the changes that I made. So if you want the latest file, you can just go to the repository and you can open the file from there. That's the reason that at the beginning of the workshop, I asked you guys to make a copy for yourself if you want to practice later for another time, if you want to replicate all these steps again in your spare time. I hope you have the copies of that. If not, I can always give you an empty copy again. Okay, the latest copy is available in GitHub, and I think it's about to finish running the training. Let's see how many episodes are done. Whenever you're rendering an environment, it takes quite a long time. It's less for custom environments that you create yourself. Unfortunately, we could not have the time to create the custom environment for today. If you guys want, if there is enough requests for it, we can always arrange another session to write a custom environment and take it from there, or you can always reach out to me. You can reach out to my YouTube channel. I might make a video on it, and if you guys want, I can cover the rest of it and put it there. Just let me know. We can actually always cover the remaining parts of it. I'm actually moving on from Q-learning to deep Q-learning as well in near future. I might extend this code and put it on my GitHub as an extension of Q-learning to deep Q-learning. Okay, sounds good. Sounds good. Looks like it's still gonna take a little bit of time. So while it's running, I can show you a bit of custom environment, how to create a custom environment. I was planning to cover it today, but we don't have enough time. I will just finish in maybe 15 more minutes because I have another presentation after this today. So what if you are not interested in games? We discussed OpenAI, gym environments. Those are all games or robotics control or some environments. For any reason, if one of those doesn't fit your needs, you can always write your own custom environments. How do you do that? Just remember the drill. Always remember the drill. For environment, you create a class called environment. For example, a transmitter receiver or a robotic arm or any kind of environment that you need for your research. You just create it as a Python class. You give it the attributes. Some of the important attributes are action space and observation space. And remember, when you inherit from gym class, from gym environment, you can use action space and observation space from gym. In gym, I showed you spaces. I'm not sure if you remember. Here, these are different types of spaces that you can use to create your action space and observation space. So I think I'm using discrete or box or dictionary. My favorite ones are basically box, dictionary, discrete, and multi-discrete and multi-binary. I haven't used these three. They're basically a combination of the others. But you can use these to basically create your action space and observation space. Box, I'm giving it 0 and 1 as a binary option for my class. You create your action space, you create your observation space. My observation space in this particular case is just time. So it's a discrete observation space. Then you can create your own reset function, which gives as output the initial state. You can create your own step function, which takes the action as input, and as output, it gives you OR, done, and a dictionary for debugging. So you can write your own step function, and how you compute reward is entirely up to you. What reward you want to give for what action is what you're going to do here. And then you have the render function, which does nothing but print some statements. So that's all that you're going to need for a custom environment. I can do a detailed video on it later, and I can answer your questions there about it. Then you can write the same training loop that we just did, that we are running right now, on that environment, and you can run it. Can you tell us how you're using this RL technology in wireless communication research, like any particular example where this is a use case? Well, I'm working on cognitive radio networks, which is a concept for efficient utilization of radio spectrum. I'm basically trying to improve internet connectivity by using reinforcement learning. It has many use cases in wireless communication, in digital controls, in basically everything. Anything that you can convert into an environment and agent. I think Mansoor wants to say something.
Yes, I think I got the question. It might be my question as well. I think so. Let me see who was asking this question. Yeah, it was Mohammed Ozair Khattak, if I'm not ruining his name. Yeah, I think he's more interested to know, like I said, it's my question as well. In a wireless communication with the cognitive radio concept, who is your agent and what is your action and what is the environment? Like it can be a notion with many problem statements, but for a basic
Absolutely.
cognitive radio, like you're sensing and transmitting or relaying in the same frequency resource, like what is your agent? What is your action?
Well, in case of cognitive radio networks, the idea is that you have primary users of the radio spectrum and you have secondary users of the radio spectrum. So one IoT device, for example, your telephone, can be the primary user of the bandwidth, and another IoT device, for example, your coffee maker, which is Wi-Fi enabled, can be the secondary user of the radio spectrum. What I'm trying to do is efficiently utilizing the available radio spectrum in a way that even when you have a lot of devices trying to connect to your Wi-Fi, all of them get good connectivity. So the way I'm doing it is the radio spectrum is divided into licensed and unlicensed bands, so your coffee maker cannot by default access the licensed bands. Reinforcement learning can help the coffee maker see if the licensed spectrum is empty. If it's empty, it can take the action of accessing it, and if it's not empty, it can take the action of not accessing it at that time. So the action will be transmission or no transmission, or delayed transmission, holding off on transmitting based on if the spectrum is available or not right now, so that it doesn't interfere with other devices.
And what is the punishment? I mean, the opposite of the reward.
Negative rewards. Just like here we did rewards 1 and 0, your rewards can be +1, 0, and -1. Normally, negative rewards are used to encourage faster learning or energy consumption, to manage the energy consumption. For example, you don't want your devices to always be participating in some process, so you associate some small negative cost, maybe -0.1 or -0.2, to discourage them from taking actions that don't lead to higher rewards.
Yes, I get your point. Thank you. I think we have one more question. If you're reading.
Do we have more than 4 states? Absolutely, you can have as many states as you want. You can have as many states as you want. Your state space and action space is totally in your control. Please let me know if you have more questions. We can take maybe 5 to 10 more minutes to answer some questions. Hopefully by that time we'll be able to show some accuracy plots. The training will be finished. Okay, let me expand the chat so that I can see the questions better. What is the research trend in this domain? Is it finding new applications using RL or developing new and optimized environments and agents? Both. The researchers who are working in purely RL theoretical domains, they are writing more agents, they are writing more algorithms. The people who are working more on the application side are applying those existing algorithms to wireless communication, to controls, to marine biology, to basically whatever field they're working in, because applying existing RL algorithms to a specific field itself is a huge field right now because it's so new and it's really efficient. It has proven to be to work so well in all the decision-making processes in RL related domains that the application of it to other domains is relatively still a new and very exciting field.
Can I ask one more question?
Absolutely, absolutely. Go ahead.
Yeah, this could be a question from other fellows here. So let's say some people are working in deep learning or federated learning, even though I know that the federated learning is a quite different discipline. So it's about like distributing the learning. So it can be like a mix of federated deep reinforcement learning. It can be any mix of this. But how this, like for the deep learning guys, how we can make a fair judgment or a fair comparison that we could say, okay, reinforcement learning is performing much better than the deep learning. So the first cost of the deep learning is needing data set. So when you do not have any data set, of course, reinforcement learning is much better. But imagine that you have data set for the deep learning as well. Now you are interested to compare which one is much better, reinforcement learning or deep learning. Is this comparison fair at all, or it's something like irrelevant and out of scope?
I would say a better question would be, what's more suitable in what particular setting? When you have a lot of labeled data and your application isn't changing on runtime, definitely go for deep learning. When you have an application which requires learning through interaction with the environment and learning from getting rewards from the environment, go for reinforcement learning. So the question of which one is better is kind of not as meaningful as asking which one is more relevant for which particular setting.
Okay, depending on the application, like so it's not a fair job to compare like a runner with swimmer. It's something
Exactly,
like this.
exactly, exactly,
Okay.
exactly.
Okay, perfect. Do we have one more question?
Okay, can we use RL for human activity recognition with initial sensor data? If so, what can be the environment and agent? Depends what kind of human activity recognition you want to do. If you want to do some handwritten or hand gestures, or if you want to uh, like what depends on your objective. If your objective is to learn what postures correspond to what thing, I think deep learning might be a better idea to go, since your uh, postures might be approximately the same, or you might already have a set of postures that you're going to deal with. But if you're expecting to learn some new postures and you want to know what exactly should be the best thing in what posture, for example, if a person is about to fall and you want to teach that uh, a robot that if a person is about to fall, then the best action is to put your hand down on the ground, something like that. Then your action space can be the movements of different body parts, and it can be in the form of a dictionary. You can have hand, forward, backward, up, down, legs, at this angle, at this speed. So you can define your action space in terms of the actions or movements of the body parts that you're controlling, and you can basically teach the agent. It's a lot similar to the robotics control or robotics walk or movement process that we saw in OpenAI gym environments, when the agents have multiple arms and they're trying to learn how to walk or how to balance themselves. So I would encourage you to explore more on those type of environments because they're a lot similar to your application. I see we have more questions.
Yeah, more questions from same person. Mohammed is very eager, like to ask many questions, so it's okay.
uh,
Which means that
like
there
deep
is somebody
learning,
who got like most of this event.
does RL also depend on huge computation resources to update its Qtable, or are Qtables have large comparable numbers for learning its like of deep neural networks? Well, it depends on your state space. For small state spaces, for example, like if you want to just write a wireless communication environment where there is one transmitter, one receiver, so you have only two-dimensional Qtable with very small size, it's much, much, much less computationally intensive. You can train it in maybe a couple of minutes. It won't even take as long as this environment that we put on 10,000 episodes and we are rendering it every 100 episodes. So it would take very minimal resources in those cases. But as your state spaces and action spaces start growing to multiple actions, multiple states, then it would start taking more resources. Okay, what's next? Mansur, can you help me with the questions? I think there are so
Yes,
many
I
I'm
think
missing.
it's a better idea. I think it's a better idea to stop your sharing, like people can see you, and I
All
mean,
right.
yeah, yeah, I can. So can you give a little idea about the? Okay, got it. So the other question is, uh, yes, I mean, the reinforcement learning is quite different paradigm, and it has been shown that it is much efficient than other learning techniques, depending on the situation that you do not have any idea about the statistics. So this workshop like was a very good introduction for those that are really interested to pursue their studies, their research, or start working on it. And I appreciate Sadia who gave us a very informative workshop, very, very constructive. And we get a lot of endorsements in the chat box, I see. And we are still live on Facebook. So officially, the time is already finished. So like so everybody, if you need to leave, so like you are free to go.
I'm sorry I could not turn my video on for this session
Yes, I
in
just
WebEx.
noticed that. Yeah, I just noticed that you're not able to do that, but I see you in live
On
Facebook.
Facebook, yes, because at one time I could only stream to like I could only use my webcam for one stream. So WebEx didn't allow me to use my stream here while I was
No
streaming to
problem.
Facebook.
No problem. Maybe I can turn on my camera. Okay, so once again, thank you everyone for attending this workshop. I just want to have like a concluding remarks. Thank you so much for our co-hosts from across the entire Canada, from Vancouver to Montreal. So we had co-hosts from Vancouver section. I see Anna is here. Anna, if you can hear me, like you can turn on your camera or voice, like if you want to give us a few words on your experience as the co-host in this event. You were like serving as the official co-host in this event. Anna, you're muted.
Yeah, there. I was trying to find where to unmute myself.
Okay.
Thanks a lot, Mansoor, for sharing this event and for allowing us to collaborate with you. Like representing not only the Vancouver section, but also the Circuits and Systems Society joint chapter of the Vancouver and Victoria sections. It was very interesting. I normally work with more like with machine learning, deep learning, and so on. But reinforcement learning, I think in my research group, we've used it a long time ago, more for network virtualization and tasks and such. So it's really, it's nice to learn a little bit more and get a better feeling on what's reinforcement learning about. So thank you
Yeah,
a lot.
the event time was like 9 a.m. in Montreal time, but I just totally forgot that it's almost 5:30 in Vancouver.
Yeah, so I didn't join from the very beginning, but halfway through. But still, I thought it's okay because, yeah, like 9, it's 6 a.m., so it's a bit early.
Yeah, anyway, like give our hello to Dr. Trajkovic. I hope I'm not ruining her name. And thank you for your excellent contributions. Yeah, we just within pandemic, and we have opportunity to collaborate with more people across the entire Canada. It's a good experience to get to know like more people like you and other groups as well. Anyway, thank you so much.
Absolutely.
And yes, I see a question about the content of this event. So it will definitely be uploaded on the YouTube channel, and it will be uploaded on our website as well. So I think there is no need to transmit file individually for all participants. So you can easily log into your YouTube account and you can stream it, or you can stream it from our website as well. As far as we didn't have any slides, I think the code that you need is already on GitHub, and I'm pretty sure that Sadia is gonna keep it over there, right?
Yes, absolutely.
Okay, perfect. So anything else? Is your channel IEEE Young Professionals? Yes, we are IEEE Young Professionals Affinity Group of Montreal section. Yeah, the YouTube channel that you're asking about, YouTube channel, if you go our website, so just, okay, it's a good question. Let me give you our website. So yes, I'm going to give everybody this link. So this is our website, and the channel, YouTube channel, is available through our website. All you need is to go to our website. If you click on one of those videos in our events, you will be redirected to YouTube channel. And so I think we're done. Hopefully you are not exhausted. And I think everybody get most of it, especially those people who ask a lot of questions. I'm really happy that it worked for all of you. Thank you, Sadia. Thank you for this great presentation. Thank you, Faye, other speaker, and thank you for all co-hosting representatives from across entire Canada. It was a great pleasure to be here today. And feel free to ask every question you have from our speakers. I think you can easily find their email addresses from our website. And you can direct your questions to them if you have more questions. And I'm confident they are welcome to answer all your questions. As far as they are very active in their social media. Sadia has her own YouTube channel, sharing a lot of stuff. You may get to know like more content from this speaker. Thank you, everybody, and stay safe. Hopefully everybody will get vaccination and we will meet in person one day. Thank you.
Thank you so much.